Sir,
Hello
the
and
workplace system.
hello and once again welcome to the fifth. Is it the fifth class, Rudra?
Yes, sir.
Fifth class on thermodynamics. I don't know the quantum of discussion that we will be having henceforth. Also, I apprehend it will take minimum two more classes of 2 hours duration minimum each. I welcome to those who are watching directly from the YouTube. But you guys who are in the Zoom, don't be intimidated or shy away in asking me questions whenever you want, and that too in our vernacular language, Odia. You are allowed, if you are not confident to speak what you are thinking in English, you are allowed to question me in Odia. Because Odia has been recognized as one of the internationally recognized as one of the regional languages. So we are proud of the language Odia. So whatever question you will ask me in Odia, I will definitely translate that in English. And if any viewer who will not be able to understand any language other than English, or not understand Odia, then there will be no problem for him or her to interact. To know what question was posed, that might be an interesting question. Yes, first question, Samidha, you were asking a question. You choose your language as per your convenience. Samidha.
No, sir, I got the answer. Yes, sir.
Hmm.
Sir, I got the answer.
Okay, okay. Anyone else?
Sir, I have sent you a
Oh, yeah,
question.
okay, okay. Okay, that we'll discuss. I have seen that. That's a very interesting question. I will discuss that in my program. But my question is, have you solved the problem I gave? Two problems I left out.
Yes,
Let me
sir.
share. Let me share my screen and show you. Uh, are you able to see my screen?
Yes, sir.
Okay. So you never bother, guys, that we are having a recording here. You feel completely free to interact with me, and don't hesitate to speak in Odia. କାହିଁକି ନା ज़्यादातर ଲୋକ ଆମର ମୋର ଯେତିକି ଲୋକ ଦେଖିବେ ବି ଦେଖୁଛନ୍ତି ମୁଁ ଦେଖୁଛି ସେ ଓଡ଼ିଶା ବେସ୍ଡ, but there is a possibility, and I have seen guys on searching mode, in Google search mode, they are also at later time they're also watching and giving me some feedback. So that is why I am trying to restrict my explanation in English, but I will take up question in Hindi, Odia, these two languages. To some extent, Bengali I can understand. Yes, Assamia I can understand to some extent, but nothing of the southern Indian languages. Absolutely, I am ignorant of that. So let us not bring language as a barrier to communicate or to have a interaction between you and me. So break that barrier. And so this was the question I gave you, these two questions. We will take this question. Omkar, have you done this question?
Yes, yes, sir. No.
Hmm?
Hello. Yes, sir.
Huh? Have you done this? Have you solved this question?
No, sir.
Why?
I was doing
Why?
the previous calculations which are there.
No, I've given 2 questions before I left you last time. I gave you 2 questions to solve, and you are supposed to being a very focused and passionate boy. You are supposed to do that. I am not expecting the others to come up to my expectation, because they have their own you know issues with which they are struggling, and also they are participating. That's a great thing. If they can somehow they can finish, they can complete the program, then it will be really benefiting them in the long run. And what is this problem, I am not going to embarrass you guys, because next time when I give some question, you must, as a matter of priority, you must solve them to make me please. Otherwise, I will leave all my interest to teach you. Now, this is a PV graph. Hold a calculator. 10 liter of a diatomic gas at 300 Kelvin and 2 atmosphere from state 1 is expanded isobarically. Say this is A. Isobarically, it is the state 2. So 1. Let us, as per the question, let us write state 1. We have come to state 2. The volume gets doubled. This is 10 liter and this is 20 liter. This is a PV graph. I am so sorry. This is a PV graph, not a VT graph. It's a PV graph, and we are depicting all processes in a PV graph. So this pressure remains constant means the temperature must be increasing with the increase in volume. Here Charles' law is applicable. Charles' law is being followed. Charles' law is being followed, so that volume increases due to increase in temperature. It has been heated at a constant pressure, say 1 atmospheric pressure or 2 atmospheric pressure, load over its shoulder. It is being expanded by heating. Initially it was at 300 K. This was at 300 K. Must be some different temperature, higher temperature here in state 2. And then the volume gets doubled. And then with respect to, now the gas expanded isothermally. Further expanded isothermally. It's a curve. Temperature remains constant throughout. So supposing this is volume V1, this is volume V2, this is volume V3. So the temperature, whatever temperature, that remains constant. And then cooled isochorically like this. Volume remains at same V3. This volume remains the same. We can call it this is 0.3, this is 0.4, but 0.4 has the same volume V3. Volume doesn't change isochorically. But here the Amonton's law will come into picture, or Gay-Lussac's law. As the volume decreases, as the pressure decreases, this is the pressure direction, pressure decreases, and that happens due to decrease in temperature. So here there will be a cooling as the pressure decreases from this to this, the temperature must be decreased. And finally, from 4 to 1, to complete a cyclic process, it has performed an adiabatic process. This is isobar, this is isotherm, this is isochore, and this is adiabat. And here this temperature is given. This is the fourth state is 200 K is given. So whatever data I am writing on these points, they are not the PV, they are other data. Sometimes I am writing temperature, volume. Volume here is 10 liter. Here a double means it is 20 liter. The volume is doubled. And here it is 2 atmosphere. So the pressure has remained throughout constant. Now the gas expanded isothermally to state 3 and cooled isochorically to state 4, temperature 200. All data we have written. So let us find out 1 to 2. This transition is isobar. You can find out the work done. It is asking, find out, depict the process and find the net work done. Process we have depicted. So net work done in the 1 to 2 process, isobar process, net work done is equal to minus P del V because it is constant pressure. So this is nothing but minus NR delta T. Whenever temperature data, volume data is not given, so temperature data you can use. Temperature data you can use, and you can find out from V1 by, because it is Charles law, you can use in a separate place. V1 by T1 is equal to V2 by T2. Volume was 10 and now it is 20. Temperature was 300. Definitely it will be 600. So T2 will be equal to 600. Yes or no, Priyani?
Yes, sir.
Yes, sir.
To see how easy the problems are. And once you understand whatever so far what we have done, then how easy the problems are. And welcome those who are watching from the YouTube source. So if you are seriously watching, then use a pen and paper, because I have told you after we finish this program, or maybe in parallel session, I will be having a very important topic of class 12, and I have invited you, but I will definitely want not all of you to join. If you join, it will be either seriously you join or not join. That means with a pen and paper. You join or better don't join. It will be a very long topic. I will make it long. Complex compounds, coordination compounds as we call, class 12. So I'll be making a formal, and it's not formal. Don't take it as a formal lecturing. Let me share one of my experiences. I don't know whether I've told you or not. Long ago, maybe 10, not 10, maybe 7 years or 6 years ago. Well, no, when Corona started, yes, not 6, 3 to 4 years ago. Just when Corona 20, after 20 April, I could not teach offline. The offline, online words were not very familiar with us at that time. We were teaching offline before Corona. But once the Corona was onset, we had to teach online, different modes, steady, R&D, regular research, how to improvise the communication. That started, and I started teaching online the same way I am doing now. So what happened, a very important topic of class 12, that is solid state. Unfortunately, the solid state has been deleted. I really wonder why and how this topic was deleted. Even it is not found in physics, as I am told. It was a wonderful topic. Mostly it is conceptual and numerical oriented. And I thought, since it is an important topic, why not we have a formal YouTube streaming, live streaming, while I will be teaching to my students here in Zoom. I did that. In the same way I am speaking now to you, I spoke in English. And then after 2 to 3 classes, of course, I was enjoying my class. after 3 to 4 classes, the best of them, among them, one of the best among them, she is a girl. Now she is an engineer working for some company. Then she told me before we started this particular statement. I will be translating in English. Sir, କିଛି ଗୋଟେ କଥା କହିବି, ଖରାପ ଭାବିବେନି। ଆପଣଙ୍କ କ୍ଲାସରେ ଯେମିତି ଫିଲ୍ ଆସେ ସେ ଫିଲ୍ଟା ଆସୁନି। I was stupefied and I was, I was taken by surprise when I am delivering with style, with English, trying to mix some British accents, and not 100% British accents I can do, it's impossible. And American accents is absolutely unthinkable. So then I realized that why the girl was saying, although she was hailing from CBSE, so-called English medium school, she was in a habit of listening to me in Odia English, mostly Odia English, and intermittently I was raising humor, which I did not use, you did not raise during those formal, at those times I was doing the recording as a beginner, as a recorder. I was beginning. The YouTube channel was being launched very recently before that. So I was a bit formal and I was not raising humor. I was meaning business because time will pass. I was trying to make everything comprehensible to my students. So, but they didn't click. So ultimately, I had to come down to bilingual language. So then things happened. And then after, the most humorous part in this episode, in this story, is that she from then onwards was addressed by me as Phil Nani. Phil Nani. In Brahmin, Oppa is called Nani, or Dei Oppa is called Nani, means sister. Elder sister is called Nani. She was Misra. So I used to call her Phil Nani, and everybody started calling her Phil Nani. तार फील आसुनी आसिलानी जमती क्लास रे मोर फील आसे से फील टा आसिलानी आई थिंक रुद्र माइट बी थिंकिंग इन द सिमिलर लाइंस एंड ऑल ऑफ यू आल्सो माइट बी थिंकिंग इन सिमिलर लाइंस फील आसुनी आपण जो इंग्लिश रे कहउचंती देन दैट फील इज नॉट कमिंग I urge upon you, you have to bring that feel, because in the future you will not be an ordinary guy, ordinary girl. You have to excel in your life. And at this stage, class 11, if you are not able to sustain listening to English and interacting with, I now authorize you to ask me question in any language you like, without fear, without any hesitation. Now come back. So then the first expansion is the isobaric expansion with increase in temperature. That is how much?
-20.
Have you calculated?
Yes, sir. 2026 Joule.
This is constant pressure of 2 atmosphere
Sir,
and
negative.
sorry, nRT, n, because pressure, we are using this expression. The total number of moles is how many? Have you found out? PV is equal to nRT. How many moles have you find out? N is equal to PV by RT. P is 2 atmosphere, and V is 10 liters. R is 0.082 liter atmosphere per Kelvin per mole, and T is 300 Kelvin. So here N comes how much, guys?
Sir, 0.8.
0.81.
0.813. So if you use this here, this expression, it is minus N is 0.813, R is 8.3 into final temperature is 600 and initial temperature is 300. So it will be a negative work because expansion work in our convention is negative. So how much is coming?
Sir, 2026,
This,
24.37.
because 8.3 is Joule, so it will come in Joule. This is minus 2000 kate 24
24.37.
Joule. So this is the first step. So let me take this. So you never bother that we are delaying. Thermodynamics in chemistry, usually 1 or 2 classes, max 2 classes, they, teachers, as I am inclined to believe, must be spending. But we have been spending more than 2.5 hours every session, and this is the 5th session, and I guess 2 to 3 more sessions will be required for thermodynamics, and then thermochemistry. That is an easy part. This is pure chemistry, calculation. This is simply calculation, thermochemical calculations. But here, understanding and calculation, both. And now let us go for the isothermal process, 2 to 3. So the work done, the formula is minus nRT log, of course 2.303 you have to bring, log V, this will be V, yes, V3 by V2, final by initial. So we know all this, minus 2.303, N is known 0.813, R is 8.3, temperature we already know it is 600 K, we know, we log, and we also know what is V2 20, but we do not know what is V3. Let us wait for a moment. Whenever we find V3, we will be using that and find the, the isothermal work done. Isothermal is also coined with reversible. They both go together. So then let us go for 3 to 4. That is isochoric. Of course, the work done is 0. No doubt the work done is 0. Therefore, it is imperative that we should go for 3 to 4, 4 to 1. That is adiabat. That is interesting. So the work done, which is equal to del U, is equal to what? N? Who can tell me? What? And what is work done in adiabatic process?
fidelity.
Now Bhaiya has told, but you guys are you are not revising things. Sometimes I feel that this method that I have adopted has gone, somehow misplanned. NCV, you have to, revise before coming to each class. NCV into delta T. This is for both reversible and irreversible. But for irreversible, minus P external into delta V. Because the temperature change is different. In adiabatic expansion, more work is done, it is the area below by the adiabatic graph, and in isobaric expansion, the work done is in the rectangle, small rectangle, against the final external pressure. So therefore the temperature drop is more in in reversible adiabatic. The temperature drop is less in irreversible adiabatic, but here we know the temperature. We know, we don't bother whether it is adiabatic, reversible or irreversible, we don't bother. So what we do, that is equal to n, but 0.813 into, this is, what is Cb? This is a
5 by,
diatomic, it is a
sir, 5 by
diatomic
2 R.
gas. It is a diatomic gas, so it will be 5 by 2 R. 5 by 2 into 8.3. And what is delta T? It is saying that it was 200, it was, the temperature is given, and it has gone, because this is compression, this is adiabatic compression, the volume has decreased, so temperature must have increased from 200 to 300. So final temperature is 300. So 300 minus 200. The compression work is positive, so it has to come positive. So what is the work done? Which is,
Sir,
1686.975 joule.
how much?
1686.
sir, 1687 approximate.
Yes, it is 1600, you are correct, 1686.97, approximately 1687 joules. Okay. Then we are left with finding the isothermal work done. For that, who can tell me how to know this volume? This volume, this is V3, this is also V2. We have taken it as V2. Sorry, this is V3, this is V3. This is V3, this is V3, isochoric process. So once we know this V3 from the adiabat, the same V3 will be applicable, which is pending. This expression is pending. V3 is pending now for real final calculation. So this V3 we can find out by using the adiabatic gas law, V1 T1 gamma minus 1, T1 V1 gamma minus 1 is equal to T2 V2 gamma minus 1. So from the adiabat, 4-1 adiabat, somehow we have to find out the volume. So this V3, this is V3, and the temperature is 200. So 200 into V3 gamma minus 1. What is gamma minus 1? Gamma is diatomic gas. How much for diatomic gas if nothing is given?
1.4.
अरे gamma minus 1 कितना हुआ?
Sir, 1.4. 0.4.
0.4.
अरे gamma minus 1, T1 V1 gamma minus 1 is equal to T2 into V2 is known, 10 into 0.4. Did you get why I am writing 0.4?
Yes, sir.
Yes, sir.
Priyani?
Yes, sir.
Samidha?
Yes, sir.
It is gamma T1 V1. You are not revising anything at all. Gamma minus 1 is equal to T2 V2 gamma minus 1. So this is the adiabatic gas law you are using to find the V3. What is V3? Can you find out for me?
27.55.
This is 27.55 liters, because This you have taken in 10 liters, so this is liter, so this will be coming liter. Now let us go back to the calculation we have left, is equal to minus 2.303 into 0.813 into 8.3 into 600 into log V3. V3 is now found out to be 27.55 by 20. Find out what is the work done in the isothermal second step.
So 1300.
Sir, I'm getting 1296.9.
Yes, 1200.
Yes, sir.
some
1296.
9. So we have done all the work done. So the total work done is the net work done during the cyclic process involving one isobar, isotherm, isocore, and adiabat. We have the first step is minus 24 point, how much? And in the second step, just now we got, and third step is 0, and in the final step, which is positive, is 1686.97. So what is the net work done? Has to be negative, because you are absorbing some amount of heat from the source, from the hot source, and throwing some residual heat to the sink. So the net amount of heat that the cyclic process is absorbing will be entirely converted to work done. So how much?
Sir, minus 1634.1.
So this much of work done by the cyclic process. So what net heat has been absorbed? What the net heat has been absorbed?
Sir, positive 1634.1.
Definitely, because in cyclic process, just like isothermal, in cyclic process, Q is equal to minus W. Delta E is equal to 0, no change in internal energy. So it behaves as if it is a isothermal process, but is really a cyclic process consisting of many steps. In this particular cycle, only one adiabatic process and one isothermal process, and the other two are one isobaric and one isochoric. But in Carnot cycle, which Carnot devised for the first time, you have an internal combustion engine. It consisted of two adiabatic and two isothermal. After that, the cyclic process changed. Whatever was convenient to them, they had the cyclic process. One of them is this. Got it? Raise your hands who have understood. If you are, watching from outside, please write down in the chat box. Hi there. Did you understand the problem and its solution? So be ready. Today will be a very hectic session. Be ready.
Sir,
Maybe.
sir, NCP delta T and NCP delta T, sir, these two formula can be applied only for adiabatic.
Anything. For anything. For any
So
adiabatic.
then for isothermal, if we will apply, then work done is
No,
zero.
not for work done. Work done only for adiabatic. Only for
Yes, sir,
adiabatic.
yes.
But for del U, for every. Del U is nothing but it is the heat absorbed at constant volume, that is called del U. So del U is nothing but NCVDT. है कि नहीं?
Yes, sir, yes.
Any question? Any question? No question?
No,
Hello?
sir.
No, sir.
No, sir.
This one you do at home once again. Eta. and I am also copy pasting another problem. ଏଇଟା ମୁଁ କରି ଏଇଟା ତ କରି ଦେଇଛି ଆଗୁଆ, ହଁ ହଁ କରି ଦେଇଛି. Somewhere I have done this problem, the cyclic process. ଏଇଟା ତ କରିବ. This one you will do. ଏଇଟା ଆମେ କରିଦେଲେ, ହଁ ଏଇଟା ଆଉ ଗୋଟେ ମୁଁ add କରିଛି. I have added one more question which you do. So 2 questions are now home task for you. Okay?
Yes, sir.
Yes, sir.
Now we shall be moving on to a very interesting aspect. That is the thermodynamics, second law of thermodynamics expressed in another format. Yeah. Now, this is the free energy, Gibbs free energy. We have just stopped further discussion on entropy change. In fact, I had in my mind to continue entropy changes little more. But I will be coming back to entropy changes after this form of second law is introduced to you. This Gibbs free energy was a necessity for chemists. In chemical reactions, mostly, this is required. Why? Because while interpreting the second law in terms of entropy change, who can tell me what is the second law definition? There are so many definitions like first law. How you define second law in terms of entropy? Yes, come forward.
So the entropy of an isolated system or universe increases or remains same in a spontaneous process.
Precisely, Omkar is correct. In any spontaneous process or natural process which will happen, then the entropy of the universe, system and surrounding together, added together, will be more than 0. It will be positive, it will increase. Or in the worst case scenario, it will remain the same. That means there will be no, the del S universe will be equal to 0. In that case, the system will be coming to equilibrium at the midpoint. It will happen, but not happen to a large extent as it will happen when del S universe is greater than 0. But then it was thought, it was very difficult to find out what change is happening in the surrounding every time. You cannot, you can monitor what is happening inside our system. But what is happening in the great surrounding, in the vicinity, it becomes, of course, for a real purpose, the surrounding, the universe, the surrounding is taken as another insulated container, a long container, to measure what is happening inside that surrounding. And there is a system inside. So it was not possible to always measure what is happening, what entropy change is happening in the surrounding. So they thought, why not we create another thermodynamic property or thermodynamic function, which will be a state function, an extensive property, which will be only for system. And second law can be redefined on the basis of that new thermodynamic function called Gibbs energy or Gibbs free energy or simply free energy. So this is the free energy or Gibbs energy is the amount of available energy. It's not really already free. It can be made free for any non-expansion, non-compression work. Forget about, because we the chemists, we don't deal with internal combustion engines and expand a gas, then compress, and this continues and we get work done, and that work done is converted to the moving of the shaft and the car runs or whatever happens. The internal combustion engine. We are not interested. We are interested in chemical reactions. So for that, we need how much of the heat that is absorbed or evolved, how much of that can be used for useful non-expansion, non-compression work other than expansion and compression. As a chemical reaction. For example, it's a electrical work done, electrical circuit. You are still, when you are dealing with an electrical cell, that chemistry works. Electron flows from a half cell or electrode having greater potential to a lower potential, it runs. Talk about that electrochemical cell later. So all this work which is not involving any, how much we can get. So the maximum energy out of del H, enthalpy, whatever change is happening out of that, how much of energy can be used for useful work, non-expansion, non-compression work at constant T and P. The first definition was at constant temperature and pressure. And usually our chemical processes, they take place at 1 atmospheric pressure, which is a standard pressure. Now it has been converted to 1 bar, which is slightly less, as you know. And temperature you can vary, but the definition goes like this. You just write down. Just write down in your copy. I will tell you what to write and what not to write. It is the energy of a system whose change, the zero or not sign stands for the standard state, not STP. Standard state for liquids and solids, standard states means 25 degrees Celsius or 298 Kelvin, and pressure is 1 atm and now 1 bar. It's not 0 degrees Celsius. For gases, STP means 0 degrees Celsius. But for liquids and solids and other things, standard state is 25 degrees Celsius. So you write down this. It is the energy of the system whose change gives the total amount of available energy to perform maximum useful non-expansion work. That is excluding PV work. That is W max during a reversible process at fixed temperature and fixed pressure. Example of non-expansion work is electrical work done during a galvanic cell I was talking about, or any chemical reaction. Every chemical reaction is just like a galvanic cell. The cell happens with the 2 different electrodes placed in a different place, and you are connecting by an external conducting wire. But in chemical reaction, particularly redox reaction, that happens inside the same solution. Electron flows inside the solution and we don't benefit out of it. So all redox reactions also, work is done, electrical work is done. So that, or work in the flow of a liquid due to osmotic pressure during osmosis. And there are many other work which do not involve PV work, expansion compression work. Del Z is a measure of the driving force for the particular reaction or process other than the PV process. Okay? And just when you have written, please raise your hand, the yellow hand, so that I will move forward. as much I will tell you, you write that only. Others you will be doing at home. I will be giving you the files. Now see, you have to write this. We have to introduce how the scientists introduced the free energy change, and then what is free energy. Now see, don't write. In the first definition of second law, we knew that delta S universe should be greater than 0 or is equal to 0. For spontaneous and irreversible process, it is greater than 0. So del S universe is nothing but equal to del S system plus del S surrounding. That sum should be greater than 0. So we have not taken del S universe. In its place, we have written del S system, del S surrounding should be greater than 0 for a spontaneous process. Now, surrounding, as much of heat surrounding will system, supposing it is an exothermic process, system releases heat, as much heat it will release, same heat it will absorb. So del S surrounding will be the Q surrounding by T. So in place of del S surrounding, we write Q surrounding by T. But Q surrounding is equal to minus Q system. So in place of Q surrounding, we can write minus Q system. Now slowly we are rejecting surrounding. You might ask how T is remaining, because definitely due to a infinitesimal change in temperature, the heat flow has happened, right? Therefore, the temperature, although we will be taking as later on will be taking as isothermal T is constant, but here T of the system and T of the surrounding, they are slightly different. Therefore, we are keeping T here, not expanding a T in terms of T here. So if you do that, then del S system plus, in place of Q surrounding, we write minus Q system by T must be greater than or equal to 0. And then so I am writing this once again. I am writing this. So at constant pressure, you know, Q, see, since we are keeping pressure constant, usually chemical processes are carried out at 1 atmosphere. So if constant pressure is the condition, then the Q will be QP, and that is nothing but change in enthalpy. So this, in place of minus Q system, we write minus del H system. So nothing surrounding is now there. So if you multiply T and you find T del S system minus del H system greater than 0. That should be the condition for spontaneity, for irreversible process. And if you multiply a minus sign, then del H system will come first, minus T del S system will come second, should be less than 0. So when we have multiplied minus, then this greater than sign will be equal to, will be changed to less than a sign that you know from class 2. Oh, I don't know class 2. So this del S system minus T del S system, this has been given a new thermodynamic change of new thermodynamic property called del G system. That means you have supplied this much of heat, out of which this amount of heat, it will be useful for non-expansion, non-compression work, and this some amount of heat will be T del S is a heat. Del S is Q by T, T get cancelled, so Q del S is heat. That will be thrown out of the system. If you are giving, system is absorbing QP, that is del H, out of which T del S will be thrown out as heat. It cannot do, just like in the expansion compression work, system and surrounding were behaving as gentlemen. Here also in non-expansion work also, the system and surrounding will be behaving as gentlemen. So whatever T del S, that amount of heat subtracted from del H, that will be the net maximum non-expansion work that can be done. T del S will be thrown out as heat, but who knows, out of that heat thrown out, some compression work might happen. Some compression work might happen out of that. But we say T del S amount is not useful. This is a non-useful heat, so it will be thrown out. But out of that, maybe some will be used for compression work or other work. So, and from this, the absolute value is Z is equal to H minus Ts. The absolute values are just for bookkeeping, that cannot be determined. The absolute enthalpy, absolute internal energy, they can't be determined. So also G. So Z is equal to H minus Ts. Z is a state function as an extensive property. Just write down this derivation as quickly as possible. And during your writing, I might be speaking something, but you don't bother what I am speaking. The guys, many guys are watching directly from the YouTube, and I'm sure those who are really passionate about studying thermodynamics will be benefiting quite a lot in our intensive discussion. And those who have not yet watched the first 4 videos, I have given the links in the description box. Also today's video, you will find description box, you will find the links of all the 4 earlier videos, and you can watch from starting till this video and then follow continuously. Over. This equation spelling is a mistake. Over.
The del G system is equal to minus T del S universe with the coherent.
Del G.
Sir, हमें जो
derivation yeah. That also I have shown. I will show in the next slide in a different way of derivation and introducing del G system. Yes, this is one way. There is another way. It over.
Yes, sir.
Yes, sir.
Yes, sir.
Now, guys who are watching, only purpose of watching, have to bear with us, because this is the title of this programs is Thermodynamics for Beginners. So we start from the very grassroots and dive deep into the subject matter, so that we can solve any question coming from chemistry or physics. And we have a strong fundamental in thermodynamics. Whenever we join in an engineering stream, which again will deal with thermodynamics, we will have an absolute command over the topic. Ready?
Yes, sir.
So show me your hand so that I will change. who have written. Krishna, you may not write. If you want, you may write, you may not write.
Sir, in notes, we have not written this process, but
Okay,
another
this
second
is
process.
another way.
Still,
If you are writing, it's well and good. I said, if you are not writing, it's also not bad. It is any over.
Yes, sir.
Now see, I will explain the same in a different way. Alternative way of introducing Gibbs energy. I started with the same thing, but I did not write greater than 0 from the beginning. I did not mention it is spontaneous process. I mentioned that del S universe is equal to del S system plus del S surrounding. So in place of surrounding, I write the same thing, minus QP by T, and then did the same thing. But T is now multiplied with del S universe. And then I multiplied minus sign as I did there. So minus T del S universe is equal to minus del S system minus T del S system. So now we will take the net change in the heat of this universe minus T del S universe is equal to del G system. The supposing increase in free energy of the system is equal to the decrease in the T delta S energy of the universe. So here it can be opposite also. If del G will be decreased, then T del S will be increased. If del G will be decreased, then T del S increased, then T del S will be decreased. So the change in the T del S of the universe, that is equal to the change of free energy of the system, but sign opposite. If one is decreased, the other one is. So then the introduction was delta G system is equal to minus T del S universe. So I thought this way is better. Then since del S, now see, if del S universe was greater than 0, positive, that means del G will be negative, yes or no?
Yes, sir.
Yes.
If for a spontaneous or irreversible process, for a natural process, and if del S universe is less than 0 for a non impossible process, then del G system will be greater than 0, positive. And if del S universe is 0, that means it will happen, but it will not come to the last point, it will come to the midpoint, then del G system is equal to 0. So it is better also to write in this way, but you write what I am writing here in a separate page, because we'll be using both. Del G system is also equal to minus T del S universe. Just write down this derivation. You can do it at home. The second alternative way to derive, you can forget. And case 1 for spontaneous is a misnomer for me, because we are handling chemical processes now. Mostly from free energy, change is applicable for chemical non-expansion processes. It is mostly used. Therefore, I will write irreversible. I will write product favored or product centric. That means it will be giving almost 100% of the product, or maybe more than 50% to be very correct. This del S universe was greater than 0, but since del S universe T del S inverse is equal to plus del G system, that means system del G system should be less than 0, negative. So when del G, henceforth we will not write every time system. Now whatever henceforth we will do, all the terms del G, del S, del T, these are all for the systems. Surrounding is out now. Surrounding is out. And similarly, S2, non-spontaneous, this carries no meaning. Reversible also is carrying no meaning. Every, the irreversible process that we are saying is also reversible. Every process is reversible. But some processes by chance are becoming irreversible, which are proceeding towards almost 100% completion. But in principle, every reaction is reversible. So a term madhya misleading. This term is also misleading to me. So product favored. This is good. Non-spontaneous, this is I will say impossible process. Impossible process, or reactant favored. That means almost it will remain on reactant favored process. That case, del S universe was less than 0 negative. Now del G system will be greater than 0 positive. So if you find del G system is positive, then definitely the process will not happen. But in chemistry, the process will happen, but to a very small extent. But as a vyapari, as businessmen, that small extent can be also harnessed, can be useful to do business. हमारे लिए कोई impossible नहीं है. अनहोनी को होनी कर दे, होनी को अनहोनी, जमाहतीनो अमर अकबर एंथोनी. हमें जोटा impossibility कहूचे, del G is greater than 0, and we shall now today correlate between del G and the equilibrium constant, how far it will go. Today we will do that. For that, some of the initial concepts of reversible reaction coming to equilibrium, we will also know that. Then only we can understand the thermodynamics of equilibrium. Equilibrium attains for every process. For what we call irreversible process, that it attains maybe 99.99% के बाद equilibrium आता है. Equilibrium आने के बाद no further change. And a so-called reversible process or non-spontaneous process or impossible process, some little change happens, but it comes to equilibrium where you find maximum amount of unreacted reactant and a very little product. That little product sometimes will be useful for our vyapar, for our business. And third case where we will not be unhappy that it will come to the midpoint. It is reversible and equilibrium at the mid position. That means, let me be very candid, that equilibrium constant is equal to 1. I will explain to you what is equilibrium constant later. That means as much a product, same is the reactant. Ice, water, 50% ice, 50%, half mole. If you take 1 mole of ice, 0 degree Celsius, the environment is 0 degree, keep it, you will find half mole, 9 gram ice, 9 gram water. It will remain at equilibrium. As long as you don't change the temperature above 0 or below 0. Above 0, it will be completely melt, and below 0, will completely freeze. At 0, it too will remain at equilibrium. That we will be doing that very soon. Here, del G system, as del S universe is equal to 0, del G system will be equal to 0. So three things. Now we shall forget about, for chemical processes, we will forget about entropy change of the universe. For that we had to measure the entropy change that is happening in the surrounding, which is too difficult for us to imagine. Now I will give you examples. The first example that I will give is melting of ice at 25 degrees Celsius. The moment you bring a ice cube and throw it in the ground, it will melt completely. Why it is spontaneous? Why it is product favored? Product means right favored. Let me write down here another term. This is right favored. If it is a physical change, it will be right favored. This is left favored. It's a physical change. Physical change is also comes under del G. It is not expansion compression. It is change of phase, left favored. So we shall prove that this is spontaneous, irreversible. We shall prove del G, we will be proving that it is negative. How? Now, this is the famous equation. Write down del G is equal to del H minus T del S. We already know this. These are all system. Cis, 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 cis. So henceforth we will not write cis, 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 cis. Right? So this famous equation is called the Gibbs Helmholtz equation in the rudimentary form. Gibbs Helmholtz. We shall write GH equation. So, and in the case of melting of ice, del H is positive because melting is endothermic. Absorbing the latent heat of fusion or molar heat of fusion amount of energy from the surrounding, so it is endothermic. Melting of ice is endothermic. फिर भी ये spontaneous है. क्यों? Why it is spontaneous despite the fact that it is endothermic? We had proved it on the basis of entropy change of the surrounding, universe exceeding zero. But here we will prove that del G is negative. I am so sorry. Del G is negative. We shall prove del G is negative. Then only a process is spontaneous. Del G is negative or less than zero, then only the process is spontaneous. Who can tell me why del G becomes negative? Del H is positive in this case. Endothermic means del H is positive. So what makes the del G becoming negative? Yes, anyone who can tell me what is the contributing factor to make del G negative? Free energy change is negative.
The ice is converted to water, so solid is converted to liquid. Entropy increases, del S will be positive, so minus T del S.
Well,
will be-
you be a silent spectator and you are becoming a very active participant. I'm asking class 11 students. Yes, I am happy that
So,
you are taking part. Huh? Yes.
so due to change of state from solid state to liquid, the entropy is increasing. So
Yes.
del S is magnitude of del S is very high. So
Yes. Del S is hugely positive. Hugely. So when a solid is converting to a liquid, the randomness, the chaos, the entropy increases significantly. So del S is hugely positive. And this hugely positive term makes this negative term, numerically greater than the positive term here. So the net result is negative. So del Z is becoming positive, negative. So it is spontaneous. And tell me, if you keep it at this T, what is when del Z, well, del Z is equal to 0, what will happen?
So
So,
equilibrium.
Yes, I told you del Z is equal to 0, that it will come to equilibrium. That means both the solid and liquid ice will remain at equilibrium, right? So 0 is equal to del H minus T del S. This is nothing but the melting point or the fusion point. This is the melting point at which this will, we can find out. So this equilibrium temperature will be equal to, del H by del S. This will be given the molar heat of fusion of ice, and this will be given the entropy change during the ice to water conversion per mole per temperature. So then the temperature that you will find will be exactly 273 K. So this is the temperature in which the ice, the solid phase remains in equilibrium with the liquid phase. The equilibrium constant, as we shall find later, will be equal to 1, 50% water, 50% ice by mole. And if the temperature will be less than, now this temperature was, this will be coming 273 K, that is equal to 0 degrees Celsius. We have taken 25, 298 K here we have taken. See, here we did take 298. So definitely del Z and del S is hugely positive. Del H is positive. This is 298. So 298 into hugely positive del S, and this is small del H, that makes del Z negative. And at 273, these two terms, del H and T del S terms, they are equal. So del G is becoming 0, equilibrium at the midpoint. But supposing I will take -2, -3, -4, say 270 Kelvin or 260 Kelvin here, then what will happen? Tell me what will happen.
then so del G will be positive and
Definitely del G will be positive.
because
Del
del
S,
S have very small magnitude.
del S has small magnitude. Doesn't matter. But del S টা hugely positive hele B. Temperature ଟା ଯଦି କମିଯିବ from the equilibrium value, ଯେତେବେଳେ 0 ଥିଲା, undoubtedly ତାଠୁ କମିଗଲେ temperature, definitely delta G ଟା ଏଠି positive ଆସିଯିବ. এটা କମିଗଲେ, କାରଣ ଏଠି 0 ହେଲା ବେଳକୁ temperature ବାହାରିଲା 273. 273 ରୁ ଯଦି temperature will be 270, 260, then definitely this negative term numerically will be lower than the positive term, and the positive term will supersede, and the net result is positive. So at T less than 273 K, you will find del Z will be greater than 0, and it will be non-spontaneous. So ice will never melt below 0 degree Celsius. Above 0 degree Celsius, you will find from the data, the entropy change data, so many fascinating things are coming. How to know the absolute entropy from the third law? Entropy change can be calculated from the absolute entropy data. We will be solving problems. But del H, del U, del Z, they cannot be measured. They have to be measured by following some rule. I mean, del H and del U can be measured by the calorimeters that I have already told you. But del Z, by using this, indirect method, by this Gibbs Helmholtz equation, or by another method which I'll tell you from the standard free energy of formation of the compounds. We'll be doing that. Now coming back to, now let me ask you one thing. Let us make a condition which we will make del H, del S, this is, and spontaneity. Case 1, del H is negative, del S is positive. Always have the GH equation in mind, del G is equal to del H minus T del S. I am not writing the not symbol, which is very important. After some time, you will find the not symbol is very important. Standard state or any other state you have to define. A defined state. So when I am not writing not, you forget that I am missing out, maybe deliberately. So what will happen to the spontaneity? Is the reaction spontaneous at all temperature? Every
Yes,
temperature
sir.
it will. Yes, if you find such a,
Spontaneous in all
yes,
temperature.
because if del H is negative and del S is positive, then negative here is also negative. Then at all temperature del G naught will be negative. Negative means it will be spontaneous. So spontaneous at all temperature. Whether it is minus 50 degrees Celsius or it is plus 500 degrees Celsius, at all temperature it will be spontaneous. But mind you, there is another villain coming. Thermodynamics, and it's exactly not enemy. It is like US and China. They are doing business. They have their interest, but they are rivals. So another rival will come in to sabotage the thermodynamics prediction. That villain is called kinetics. Kinetics and thermodynamics, they, in many occasions, they do not go hand in hand. They do not go hand in hand. We'll talk about that later. And now the second case. Supposing this is negative and this is also negative. Or suppose this is positive and this is negative. Then what will happen?
Sir, the process will never happen. Impossible.
This is never possible at any temperature. If this is positive and there is a decrease in entropy, so this minus minus becomes plus and this is already plus. So this will be del G will be plus. So it will impossible process. Non-spontaneous at all temperature. Three. Positive, positive, negative, negative. These two things are left. Tell me if positive, positive. You have to answer
Sir,
in this. Yes.
Sir, it depends on temperature.
Yes, you have to answer. Is it spontaneous at higher temperature or lower temperature? You have to answer in this way.
Sir, spontaneous at higher temperature and non-spontaneous at lower temperature.
No. Only you say about spontaneous. It is indirectly it will mean that. So if del H is positive and this is positive, there is a minus term in the middle. So temperature will control. If the temperature is higher than the equilibrium temperature, then the negative term will supersede. So this is spontaneous at higher temperature. Just qualitatively let us write spontaneous at what is that higher temperature. It varies from process to process. First you have to find out the equilibrium temperature. I mean where del zero will be equal to 0. This is midpoint temperature. I used to call midpoint temperature. Then You have to say above that equilibrium. That, I never ever like that term equilibrium temperature. Equilibrium happens to all processes, whether it is a highly irreversible process or a highly non-irreversible process, a left favored process, or midpoint. So they all are, confused. Unless you understand and solve problems, you will be in confusion, super confusion. Yes, you have done thermodynamics, but without any real concept at higher temperature. Therefore, we'll be solving a lot of problems. We don't bother whether it will be delayed or yeah, this is our modus operandi. And then negative, negative. Tell me, if this is negative, this is negative, this term will be positive. Then
So spontaneous at lower temperature.
obviously, if this is negative, this is positive, and supposing T is high, so the positive term dominates, so it will not happen. Del G0 is positive. But if you lower the temperature, then T del S, which has become positive, the numerical value becomes less than the negative del S term, then del G0 must be negative. So here we have to mention spontaneous at lower temperature. We shall be solving problems. Then these are the 4 conditions where Jasmine Raul, hello. You know, हाथ हिंदी में क्या है? दिल थाम के बैठ लो, अभी क्या क्या होने वाला है आज. दिल थाम के बैठ लो. आज इंडिया में तो 8 बजने को है, तो हम तो स्टार्ट किए थे 6:30. यूजुअली 2 आवर्स मीन्स 7:30 8:30. तो इस हिसाब से हाफ एन आवर इज देयर, बट आई डोंट थिंक will be at least spending 3 hours. Are you ready, guys?
Yes, sir.
Yes, sir.
So feel some food, a fuel to your motor inside working. I am also feeling.
Sir, I have to leave the class early.
What?
Sir, I will leave the class early.
You will leave it and watch it later, right?
Yes, sir.
Because it is being recorded, and if you are really passionate, if you have some other work, you can leave and watch the video. Now see, here I'm just reading it out. Free energy is a concept that has been inducted to incorporate the entropy change for the universe, that is system plus surrounding, into change in a state function of the system. Instead of bringing universe, which includes surrounding, we only take system into account. So a new term introduced was free energy or Gibbs energy. Free energy is a way for us to think about the second law of thermodynamics only from the perspective of system. Now, you don't need to write this thing. This you will write at home, but definitely write at home. What? Z, the absolute value of Z just is theoretical. You cannot find the absolute value of Z is equal to H minus Ts, because del Z is equal to del H minus T del S at constant temperature. So therefore, the absolute value Z is equal to H minus Ts. So if you write in place of H, you write E plus PV, then G is equal to E plus PV minus Ts. You know what is E, you know what is PV. PV is just a theoretically defined energy required to make space or volume by displacing a portion of the surrounding by the gas. This is the PV energy of the gas. Del V is important. PV energy is simply a definition. Ts simply a definition. T del S is the amount of heat thrown out from the system, the energy which is thrown out of the surrounding as heat. But कभी कभी मेरे मन में ख्याल आता है, जो थ्रोन होता है इसमें भी फिजिक्स आ जाता है, ये सराउंडिंग इज ऑल्सो वेरी कूल। वो कहेगा क्यों सब हीट ले लूं, कुछ हीट को मैंने वर्क में कन्वर्ट कर दूं, कंप्रेशन कर दूं। And G is the residual part of the enthalpy which can be made available. That means the delta G will be made available for the non-expansion, non-compression, reversible work at constant P and T. Here we have made P always constant, T also kept constant. But later on in our higher level discussion, P will change, how G will change, del G will change with pressure, how del G will change with temperature. Those are very finer level discussion that will happen later when we amalgamate, mix first law and second law together. We will have many other things that will come up. We have already known that. Already known that, no need to write. If you can write down this much, you can write down. The standard state means pressure 1 atmosphere. Actually, now it is 1 bar. Temperature standard state means 25 degrees Celsius. Molarity, because we will be dealing with concentration of different solutions. So that is 1 molar concentration of solution. This we have already written down. What is Ts energy? This is a repetition. And del G naught is a useful tool to predict the spontaneity of a process. If del G naught is greater than 0, nothing will happen. Nothing will happen. हमने व्यापारी हैं, हम बिजनेसमैन हैं, इसमें भी अब देखोगे when delta G naught will be greater than 0, positive, the equilibrium constant will be coming less than 1, not less than 0, less than 1, maybe 10 to the minus 5. 10 to the minus 5 is 0.0000 4 zeros and 5. If that is the state of a chemical reaction, how bogus is that reaction, how uninteresting is that reaction. फिर भी हम व्यापारी जो हैं, इसको भी हम लेते हैं, थोड़ा सा जो प्रोडक्ट निकलेगा उसको हम इकट्ठा करके करके हम व्यापार करेंगे, जाएंगे। हमारे लिए कोई भी चीज ये नहीं है, अनयूज नहीं है, सब यूजफुल है। फर्स्ट 4 लाइन्स लिखि दियो, स्टैंडर्ड टेम्परेचर और स्टैंडर्ड स्टेट स्टिपिनो स्टैंडर्ड स्टेट कहले आमे टेम्परेचर टा 0 डिग्री सेल्सियस नौनी, we take 25 degree Celsius and molarity of solutions हमें बाहर करिवा, कारण हमें नॉन एक्सपेंशन वर्क करिवा, एतरे सॉल्यूशन आसीबो। A Besna Koribani will be doing galvanic cells where concentration will come. Lekhidala, over, raise your hands. Oh, hello, Hilal Banerjee is writing, who are you? I am ex-professor of chemistry. I really shy away to write doctor because otherwise doctors, I am not a doctor who can treat you. But people call me Dr. Sudhanshu Tripathi, S. Tripathi, Sudhanshu Sekhar Tripathi. I retired from Ravenshaw University as a chemistry faculty. Long ago, I took voluntary retirement. And now, and for the last 22 years, I am engaged in popularizing physical science, both physics and chemistry up to class 10, and only chemistry in class 11 and 12, leading the students to get a good position in all India competitive tests like IIT Advanced and NEET, now NEET. Erstwhile it was AIMS and many other things, but NEET is controlling all the medical examinations. Krishna, am I right?
Yes, sir. NEET is controlling it.
Okay, we'll go next. Now, during the process, what happens to E or U? What happens to internal energy? When we are carrying out some non-expansion, non-compression work, then what happens to E? U remains constant. Because when T remains constant, now this Ts is thrown, T del S amount of energy is thrown out. That cannot be converted to non-expansion, non-compression work. Then the temperature remains constant, means the internal energy also remains constant during the process. So need not write down this, it is there, you write down at home. It's not important at the present moment. Now, this you have already written. Only write down when the process is spontaneous, product favored or right favor. In between bracket, write down equilibrium constant is greater than 1. Just write down. We will be today calculating what is the equilibrium constant. Although chemical equilibrium chapter is next, but we will be having some initial concepts to know how to calculate the equilibrium constant from del G naught values. And such processes are called exergonic. Just to write down exergonic. In the same, don't write all these things, we have already written. Exothermic means the enthalpy change is negative. It is a heat evolving process. Exergonic means it is a spontaneous process, right favored process, product favored process. And if it is del G naught is positive, as we say, it is impossible process, it is non-spontaneous, reactant favor or lead favored, equilibrium constant is less than 1, it is called end ergonic. This is exergonic and ergonic. And when G naught is equal to 0, process will reach equilibrium at the midpoint. The equilibrium constant, this you have written, is equal to 1. Under this equilibrium condition, the temperature will be del H naught. Instead, we shall write the equilibrium temperature is equal to del H naught by del S naught. At that time, del G naught will be equal to 0. So instead of writing this, should have written, oh, okay, both are equally important. The change in entropy will be equal to that the equilibrium heat absorbed or evolved, that is called the molar heat of fusion or molar heat of absorption, molar heat of vaporization, I'm sorry, divided by the temperature, the fixed temperature at which this entire process happens. Over?
Yes, sir.
Over?
Yes.
And this table we have already done. Yes or no?
Yes, sir.
Yes, sir.
Now see, these are the examples which you will write at home in your copies. No need to write here at all. Some spontaneous chemical and physical processes. Sugar, salt, most salts dissolve in cold water spontaneously. Why? I told you there, chemical bond, when we were discussing chemical bond, I told you because of the entropy factor. Most of the salts dissolve endothermically. This is positive, most, excepting acids and bases. Most other salts that dissolve endothermically. Can anyone tell me, I had told you other than Bhaiya, this heat of solution del H when you add some sodium chloride solid to water and just leave it for some time, or simply stir at the same temperature just to facilitate it dissolves spontaneously, then that del H is what? The heat of solution is what? Which I said is positive. I give you a hint. It is a sum of two different energy terms. I have spelled out
So,
when I was.
sir, lattice energy and Henderson energy sum.
Yes, it is a sum of lattice enthalpy or lattice energy, which is positive here because you are breaking the lattice, and hydrogen enthalpy is always negative. The sum of these two is called heat of solution. That is delta H. That is, for most salts, it is positive. Why then del G is negative? Because del S is a huge factor. Even the temperature is room temperature, which is definitely above the equilibrium temperature, undoubtedly, since we are observing the phenomenon of dissolution, spontaneous dissolution of most salts at room temperature 25 degrees Celsius, then we are sure that delta G is definitely being negative, and this is due to the hugely positive del S factor. When it dissolves, the ions, they move randomly, and that increases the chaos, the randomness, and entropy increases, del S is positive. So similarly, ice melts at room temperature, we have already discussed. Water evaporates at any temperature, it evaporates. Same thing, if you calculate del G, 100 degrees Celsius, it will be coming at equilibrium. Both the phases will remain. Below, I am talking of below, maybe 90 degree, maybe 60 degree, you take the values, you will find del G will be coming negative, spontaneous. So, and most of the double displacement reactions, single displacement reactions are product centric, right favored, spontaneous, is because del G we will calculate in our electrochemistry program. We shall calculate what is del G naught, and we will find, well, del G naught is negative, it is spontaneous. Today, from del G naught, we shall find equilibrium constant. It may come greater than 1, which we shall be happy. This is product centric. We'll be finding less than 1. If it is closer to 1, then we'll not be that much unhappy. It will be very, very less than 1, 10 to the minus 5. Still will not be unhappy. We are chemistry people. Chemistry. Chemistry between you and me is good means love between you and me is good. Chemistry is synonymous to love. So we will also be happy if we find del G naught is positive and K equilibrium is coming very, very less than 1. Even then we will be happy. And osmosis is spontaneous. Diffusion of gases. Confined gas expands to volume is spontaneous. Hot body is cooled down by transferring heat to surrounding. When you take a hot body and leave it open to the surrounding, which is at a lower temperature, the heat spontaneously flows. All these cases you find the del S universe is increasing, is positive. Now we have forgotten about del S universe. We have taken del G system will be decreasing for a spontaneous process. In that, no expansion and compression work takes place. We already, when you are carrying out a non-expansion, non-compression work, then whether compression work will be happening, then that depends on the mercy of the heat that is being thrown out to the surrounding. The surrounding might be gentle enough to spend some of its energy to have some compression work. That is separate. But usually doesn't happen. Usually. Practically, some of the heat may be engaged in doing some expansion compression work. Now, these examples, there is no point in writing. And interesting thing I am telling you, the villain Who is your favorite villain? I don't know. Nowadays, I am not watching movies. I don't know who are the present villains. I can tell only the villains as we call Bhilian. In our times, I can say that them. But now, Omkar, who is your favorite villain? Villain?
Sir, from Marvel, Thanos.
Eh?
Marvel, sir, Thanos.
English villains.
Yes, sir.
Bah, bah. And Rudra?
Sir, ମୁଁ ଏତେ movie ଦେଖିନି.
Very good. And these girls, Samidha, do you watch movies?
No, sir. Lately, I haven't.
Very good. Yani also very good. Acha, listen, the villain will come and make things complicated. So the slogan is, when thermodynamics say no, it means no. When thermodynamics says no, it means no. That means when del G0 is much greater than 0, equilibrium constant is much less than 1, 10 to the minus 5. It means the reaction will happen. If it will not happen, for general purpose, reaction will not happen. Since we are businessmen, we will extract everything out of it, but it will not happen. So if thermodynamics say no, no means del G naught is greater than 0, equilibrium constant is much less than 1. It means no. But when the thermodynamics say yes, del G is hugely negative and equilibrium constant may be hugely positive, 10 to the power plus 5, 10 to the power plus 10, then you will be very happy. Huh? Thermodynamics is saying that is predicting that the reaction will be 100% complete, nearly 100% complete. You will be happy and you will be dancing. But when you come to the reality, you will find reaction is not happening. The villain is coming. The kinetics is coming. Kinetics is to do with speed. 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 Rate of reaction is the department of kinetics. Has nothing to do with thermodynamics. Thermodynamics tells us how far it will go, what is the equilibrium constant, how much product will be formed, how much reactant will be staying back, what is the free energy change. This much it will give, but it will not tell you how fast, how slow. But if such a reaction where del G was hugely negative and equilibrium constant was hugely greater than 1, 10 to the power 10, if that reaction is very slow, almost the rate is 0 at ordinary condition, say 25 degrees Celsius, even 100 degrees Celsius, the rate is as close to 0, then how long, how many years you will wait to get some percentage of the reaction to happen? We know 100% reaction will happen nearly. Theoretically, 100% is not possible, but nearly 100% is possible if 10 to the power 5, 10 to the power 6, 10 to the power 10, this comes as the equilibrium constant, then nearly 100%. So you be dreamful of that. But the villain will come, it will not allow to happen so slow. Then you have to raise the temperature. Yes. If it is slow, del G, if kinetics is also is directly proportional to temperature. Only directly proportional to temperature. Rate will be more if temperature will be more. For every 10 degrees Celsius rise, approximately the rate increases between 2-fold to 3-fold. But again, for kinetics, thermodynamics plays a villain role. Sometimes with increase in temperature, the rate decreases. Because for a complex reaction, as you see, that thermodynamics and kinetics are taken together to build the rate law. Bhaiya knows. So there, the equilibrium constant term is there along with the rate constant. Rate constant always increases with temperature. But equilibrium constant, as we shall see today, might decrease with increasing temperature, as we shall see today. So the cumulative effect, these are multiplied. The cumulative effect might be decreased. So if you are increasing temperature, kinetics will always say there will be increase in rate, but you are finding decrease in rate. Because here the thermodynamics is villain. We'll talk about that later, don't be confused. Now we are saying that if you raise the temperature to 500, then if you find delta Z was negative, now delta Z at that temperature is positive, and equilibrium constant is much less than 1, 10 to the minus 5. It was 10 to the plus 5 at room temperature, and now it is 10 to the minus 5 at 500 डिग्री सेल्सियस. फिर भी आपको वही टेम्परेचर लेना पड़ेगा, इसको बोलते हैं ऑप्टिमम टेम्परेचर, वी कॉल इट. That optimum temperature, the temperature has to be optimized by industry people to see at what minimum temperature there will be some little yield to which we can market. If we make a continuous process, we can market, we can have some. And equilibrium does not come much delayed. Much delayed it doesn't come. So at below, supposing in the manufacture of ammonia, see this example, nitrogen and hydrogen, you see this example, del G is negative at 298 K, means standard state, 25 degrees Celsius, and Kc that we found out, we shall after some time we will know how to find equilibrium. Kc means equilibrium constant. Equilibrium constant actually is 6 times 10 to the power positive 5. So you are very happy, but the reaction almost doesn't happen at this temperature, as the reaction is extremely slow, close to zero. When we calculate, and I'll be giving you another example where ammonia, yes, when you carry out at 500, you go on increasing the temperature between 450 to 500 degrees Celsius. The rate is good enough so that the equilibrium does not come long delayed. It comes after some reasonable time period to which a businessman can wait. He can compromise with small quantity because he can recycle the process, but cannot compromise the delay. So 400 to 500, 450 to 500 degrees Celsius, let us say 500 degrees Celsius, we found del G has turned from negative to positive, and Kp has turned from 10 to the plus 5 to 10 to the minus 5. फिर भी this condition is taken in the Haber's process, although the reaction seems non-spontaneous for other people, non-chemistry people, truly reactant favored, really. But this temperature is found to be the optimum temperature for the reaction from kinetic consideration, and the Haber's group, the Haber synthesis process follows the temperature, takes the temperature between 450 to 500. Above 500, the yield will be intolerably poor, as we shall see just after some time. If you raise the temperature in the exothermic process, the equilibrium constant will decrease. As we shall see, then equilibrium constant decreases means product concentration will be very less. So much less than marketing cannot happen. If we lower the temperature below 450, then although the yield will be more, lower the temperature, greater is because at temperature 25 degrees Celsius, it was 10 to the power plus 5. So at 100 degree, it will be definitely 10 to the power plus 4 or 10 to the power plus 3. So it will be more, but it will be long delayed. Reaction rate will be slowed down. So the industry people, they always compromise between rate, kinetics, and thermodynamics. They arrive at an optimum condition where kinetics is reasonably good and thermodynamics is not unreasonably poor. So that compromise temperature is called the optimum temperature. You got it, guys?
Yes, sir.
Yes,
So
sir.
biotism, Biotism is a very funny name. Biotism writes, can you clear my doubt, sir, please? What is skibidi gat equilibrium? Skibidi gat equilibrium. I am unable to follow your question. Biotism. You are a great teacher. Thank you so much. But I will definitely try to, decipher, understand what do you mean by gat equilibrium. Skibidi. Skibidi gat equilibrium. Okay. If you have written wrongly some words, you can rectify and elaborate what you are really wanting to know, which equilibrium you are really wanting to know. If it is really skibidi gat equilibrium, then I will let you know in due time. Don't worry. Yes, we are back now to solve some problems. So, what is the slogan? Let me ask you, who can tell me the slogan? Yes, Samidha. What is the slogan? Write down the slogan in your book, in your copy. Samidha,
Yes, sir.
tell me the slogan. Maybe since you are a singer, you can put it in a, particular thought, particular uh, song format. Hmm. Yes. Hmm. Tell me, okay, without song format. Tell me. Hmm. Priyani, what is the slogan?
Yes, sir.
Hmm.
When thermodynamics says no, it means that. When it says yes, it means maybe.
It means when it says yes, it means
Maybe.
it may be. ही पर no पर it हो सकता है, नहीं भी हो सकता है. Supposing the kinetics favors thermodynamics. At room temperature, rate is also good, and equilibrium constant at room temperature is coming 10 to the plus 5. So सोने पे सुहागा. Thermodynamics saying it is a favorable reaction, you can go till end, almost till end. And kinetics at 25 degrees Celsius, the kinetics is quite good, quite high. Then सोने पे सुहागा. It may be. It is yes. But in many occasions, they go in opposite direction. At room temperature, the reaction rate is so slow. Even if equilibrium constant del G is highly negative, equilibrium constant is highly greater than 1, even then the reaction doesn't happen. So once you raise the temperature, you find del G naught becomes positive, and K equilibrium constant becomes less than 1. Then you have to do that. You have to optimize to what temperature increase you can go, so that you will have to not sacrifice much of time, and also not compromise with a very small amount of the product. There will be some reasonably good amount of product, right? Many reactions having del G negative but react very slowly. Example I have given you. Even phase transition, which is a physical change which you have already known, that del G naught is the equilibrium temperature at which the melting occurs. Then you can find out melting temperature is equal to the molar heat of fusion by molar heat of the heat coach, the molar entropy change during fusion, entropy change during fusion, that will give you the melting point. Similarly, in the freezing, during vaporization, at the vaporization, I mean in the boiling point, which is 373 Kelvin, 100 degrees Celsius or 373 Kelvin, you can find out if the molar heat of vaporization data is given, entropy change data is given, then you can find out. We know it is 373. Any other liquid, supposing you do not know, or you know the boiling point, you do not know what is the entropy change, you can find out the entropy change at the boiling point if the molar heat of vaporization is given. So at temperature less than melting point, del G0 is positive, melting will not happen. We already know. Similarly, at the temperature less than boiling point, water will not boil. Del G is positive. You can calculate that. If T is greater than boiling point, above 100 degrees Celsius, it will 100% boil, not 50-50. 100% boil and turn into vapor spontaneously and completely. Now, here I will be taking you how to calculate some principle that we will follow, that is from thermochemistry, which we shall be learning in details in our next program. Maybe after
Sir, I
2 to
can
3.
do.
You are leaving?
Yes, sir.
Okay, bye.
Thank you,
But
sir.
we are staying. Biotism. We are staying maybe for 1 more hour, because we are prolonging the discussion to go dive deep into the subject matter. Therefore, guys, if by any time you guys feel really monotonous, please tell me, sir, let us stop it here. Don't feel, uh, particularly it is for Omkar, Rudra and Swami, who are with me now. Now, supposing you are given a reaction like, say, calcium carbonate solid, you are heating it, calcium oxide solid and carbon dioxide gas. And in the data, thermodynamic data table, you will find the free energy of formation during the formation of 1 mole of calcium carbonate, 1 mole of calcium oxide solid, 1 mole of carbon dioxide gas. What is the free energy change? Del G naught. That has been found out from actually del H naught. Del H naught is really measured, and del S is also found out for that formation of 1 mole of any compound from its corresponding elements, calcium solid plus carbon solid plus oxygen gas, then calcium carbonate. This is not a real happening, but by using Hess's law that we shall study, we can find del H. Once we find del H, we find the individual entropy data. They are all available for all elements at any temperature, standard temperature. It is given. So we can find out del S from the data table. Del H naught we will find out indirectly. Some enthalpy change we will find, but not this, the heat of formation as we call, we cannot find, but indirectly we can find heat of formation experimentally, and using this we find what is the free energy of formation of each compound, and for each element in their standard state the enthalpy change is 0, and so also the free energy formation is also taken to be 0. Because there is no entropy change, it is not changing, so therefore del S is not 0. So if the enthalpy of formation is 0, then del G 0 is also 0. So wherever you find any element coming in the standard state, it will be 0. And to find out the change in free energy, that means right minus left, product minus reactant, you have to take the individual component in the right side, multiply with the required coefficient, 2, supposing here 3, because this is per mole basis is given in the data, then minus the reactants, similarly taken 2 into 3, all that. So this difference of the sum of the free energy of formation of all the right components minus the sum of the free energy of formation of the left components, you can find out what is the net free energy change during the reaction that you are trying to study. So once you know del G is naught is how much, then you will say if it is negative, you will say at this temperature, at standard state, it is possible. No need to raise the temperature. If it is greater than 0, you will predict it is a reactant favored or left favored process. It will never happen. We can't say it will happen, but to a very small extent. And if it is fortunately coming 0, then it is good. It will happen and the equilibrium will come to the midpoint. Right? You just write down this. This, because we will be solving problems, you just write down this. Guys who are watching from a distance, please, you can, or at a later time, if you are watching, please stop it and record the time. You watch for half an hour today, next half an hour next day. So, but watch till the end. May not be in one spell, in one go, but watch till the end. You will find so many interesting aspects of thermodynamics. These guys who are with me in Zoom, I think they have the faculty, the patience, most importantly, the patience to continue till 9:30. What, Samidha? Will you be fatigued?
No, sir.
If so, then ask your mommy to provide you a cup of Bournvita, or maybe, but to be very frank with you, I didn't tell you to discourage you. You should have attended that class, even if with a blank mind, even if you have not, maybe you have not completed the home task, doesn't matter, but you should have at least spent 2 hours time without thinking anything, should have spent time with us. But anyway, you thought it will affect my preparation for the test. That is your decision. You must stick to that. But what we thought, I was also discussing with your mom, we thought that you should have told me that I was busy for preparation. I have not done home task. I would have definitely said, no worries, join. A later time, you can complete it. Right? Written? Written?
Yes, sir.
Yes,
Then
sir.
should have raised your hand. Now see, these are the tables I have borrowed from different sources. The del H, the heat of formation data. If you are required to use heat of formation, same principle, right minus left. Supposing entropy change data is given, the individual entropies are given, enthalpy data is given, enthalpy change data. Enthalpy data is never, enthalpy change data is given. Then you have to use the Gibbs-Helmholtz equation. If the free energy of formation data is given, there is no need of Gibbs-Helmholtz equation. Straight away, right minus left, you see whether it is, and from that you can find equilibrium constant. That we shall be doing today. So one column del HF, the heat of formation, the enthalpy of formation, then the free energy of formation in kilojoules per mole, and this is the absolute entropy. Entropy absolute values are determined from third law of thermodynamics. Therefore, the entropy values are fondly called third law entropies. Third law entropies. These are the absolute entropy at the standard state. These are the values. And right minus left, the number of moles will be multiplied, right minus left, to find out del S. So del H minus T del S will give you del G, or simply del G. So I have given you so many things. In another table, in another table, in another table, in another table, and here is an example. Now, just listen, just listen. We will be solving problems. आपको मैं नहीं छोड़ूंगा unless we solve some problems. Ammonium nitrate solid dissolves spontaneously This is dissolution. That is heat of solution. As I told you, that is the sum of lattice enthalpy and the hydration enthalpy. And most of the cases, it is positive. Now you have find this is 28.05. This is the sum of the lattice enthalpy of ammonium nitrate plus the hydration enthalpy. Negative is hydration enthalpy. Positive always is lattice enthalpy. So the sum total is the heat of solution is given. And the entropy change is directly given. By using del G naught is equal to del H naught minus the temperature is 298 K. I have found out. You need not have to find out. It is coming minus 4.36 kJ. Hence, the dissolution process is spontaneous. Many ionic compounds have greater Le than He. That means sum total is positive, like this. Still, they are soluble because of entropy factor, because of delta G naught factor. Because of the entropy factor, del G naught is becoming negative. We are not now taking surrounding del S of surrounding and adding del S system plus del S surrounding. That has to be greater than 0. We have forgotten that. That is required only for expansion, compression, all that. The entropy changes which you have left at some point, and we will be back after we complete the Carnot cycle and other cyclic processes. Now, another example which I have already given you, Kp. Now, let me tell you the equilibrium constant. There are many types of equilibrium constant. One is called Kp with respect to pressure, partial pressure. The other one is Kc with respect to concentration of the solution. So, by default, ଆମେ जो Kp ଆମେ जो equilibrium constant पाइबा from del G naught value ଆମେ କରିବା ଏବେ ଆଉ ଟିକେ ପରେ, they are Kp if at least one gas is present. Multiple gas kele bhalo. If there is only one, at least one gas component, then it is Kp with respect to partial pressure. I will tell you what is Kp and Kc later. They are similar, but they are different. The idea is same, is Kp is large, then more product is formed. So also Kc. If Kc is less than 1, then there will be very limited product, very large amount of unreacted reactant. If Kp or Kc is equal to 1, then 50-50, right? So this negative value which gives Kp is so high, this we have already discussed. There is no point. 2NO2 to N2O4, this is dimerization of nitrogen dioxide, which is a reddish brown gas. And when it dimerizes, because you already know that it is having an unpaired electron, and these two unpaired electrons, they handshake and form a bond to form a single bond between nitrogen, and it is this is a dative bond with a formal plus minus charge. And this is N2O4 is diamagnetic. NO2 is paramagnetic, containing one unpaired electron, which handshakes while dimerization happens to N2O4. And during the process, del H is this much. Del S is hugely negative because two molecules become one molecule. So there is a decrease in entropy, and del S has been found to be this much, del S has been found to be this much. And on calculation at 100 degrees Celsius, it is coming plus 8.4. So that Kp is less than 1, 0.067. And we know if del H is negative, del S is negative. So tell me, this is spontaneous at what condition? We have made a table. We have made a table. If both are negative, del H is negative, del S is negative, then it is spontaneous at what temperature?
So lower temperature.
Lower
temperature. Then only the negative term will supersede the positive term, because the middle term containing T del S has become positive because del S is negative. But if T is lower, then the positive term at some temperature will be lower. In such a case, as you continue to lower down the temperature from 100 degrees Celsius to 0 degrees Celsius, del G turns from plus 8.4 to minus 9.2, and Kp found to be 58. is more than 1, quite high, quite good. And minus 78 degrees Celsius, it is the temperature of dry ice temperature. The del G naught is this much, and you are getting Kp 10 to the in the order of 10 to the power plus 6. And if minus 196, this is liquid nitrogen temperature, it is still as del G is minus 43.7 and Kp is 10 to the power 29. These are all but at such a low temperature, the kinetics will definitely play a villain role. It will make the process so slow that it might not happen. So, you have to optimize the temperature. And in fact, the dimerization takes place at 0 degrees Celsius is good enough. 58 we are acceptable, but if you make a dry ice temperature, then although the yield will be more, conversion percentage will be more, but it will be very, very slow down. Kinetics will play a villain role. So we have to optimize the temperature. So usually dimerization takes place at 0 Kelvin, 0 degree Celsius. Got it? You have to write all these things. More you write, more confident you become. But since these are our examples, I am not asking you to spend time on writing while the deliberation is on. Ready?
Yes, sir.
Similarly, ammonia reacting with oxygen giving you NO, nitric oxide and water. That is done under very stringent condition. While del G0 is so hugely negative, and equilibrium constant, as we shall find the method to find equilibrium constant, will be so high. Still, we need an optimum temperature of 800 degrees Celsius and so much of catalyst, because the reaction is slow at room temperature. Unless we make the temperature 800, and that too, we apply catalysts, it will not happen. Pakad ke baitho. Thermodynamic is saying is 10 to the power 10 to the power 20. The equilibrium constant is observed 10 to the power 10. Be happy. Who bothers? But the villain will come and will not allow it to happen. So you have to increase the temperature. The moment you increase the temperature, if it is exothermic process, here I have not given whether it is exo or endo, then definitely there will be a decrease in equilibrium constant. Equilibrium constant decrease means del G has become positive. If it is less than 1, the del G has already become positive. So you have to adopt that temperature, no way out, because the rate has become so low at low temperature, but at say 800 degrees Celsius, the reaction rate is good. Even if the product yield percentage of product will be so less, we are happy. Similarly, the opposite of dimerization is to decompose N2O4 back to the monomers nitrogen dioxide, reddish brown gas. Del G0 is plus 2.8, very small. So although equilibrium constant will be less than 1, but it is very close to 1. It's not 10 to the minus something. So it is reactant favored, but reaction does occur to give appreciable quantity of the product at room temperature, as del G naught is, is not highly positive. So it happens simply ଟିକେ temperature ବଢେଇ ଦେଲେ ଶୀଘ୍ର ହେଇଯିବ. But you don't be biased that since K equilibrium constant is less than 1 at room temperature, it will not happen in 2O4. At room temperature also will break down and some amount of NO2 will be formed. And once reddish brown gas NO2 formed is by some method is removed, as we shall see in chemical equilibrium chapter. If you remove a product selectively, then the equilibrium will be further driven more and more to the right, and you can continue the process till end. Right? We shall be studying the fascinating aspect of equilibrium later. Similarly, water dissociation into H plus and OH minus, del G is hugely positive. That means Kw, that means the equilibrium constant will be so less. Yes, the dissociation is very, very less. That is course, if you raise the temperature 100 degree, then you will find all water will vanish, vaporization. But if you keep it under high pressure, then Kw will increase, no doubt. But del G not will not be becoming negative at any temperature, right? Similarly, nitrogen and oxygen, giving you NO2, this reaction del H is hugely positive, and del S naught is negative. So what happens when del H is positive and del S is negative? Then what?
The
Del
process is impossible, non-spontaneous.
non-spontaneous, and del G0 is found to be this. Even if it is this, it is non-spontaneous. The reaction is not spontaneous at any temperature. Instead, the forward reaction is non-spontaneous. The reverse reaction is spontaneous. The reverse reaction del H is minus 33.2 and del S naught is plus 249. So reaction is spontaneous. In that case, decomposition of NO2 to N2 and O2 as thermodynamics predicts is spontaneous. However, in the real situation, this is so slow that NO2 exists at room temperature almost indefinitely. It will never ever break down to nitrogen gas and oxygen gas. Though thermodynamically very much unstable, says that NO2 will break down to nitrogen and oxygen, but it never happens because kinetics plays a villain role not to allow the decomposition. Just like hydrogen and oxygen gas, if you mix hydrogen gas and oxygen gas, you then break your forehead into pieces, they will not form water, because again you will find del Z naught is negative and K equilibrium is quite high, 10 to the power plus something, still it will not happen. युग बीत जाएगा, हाइड्रोजन ऑक्सीजन के साथ रिएक्शन नहीं करेगा, लेकिन एक स्पार्क लगा दो, एक मैच बॉक्स, एक मैच स्टिक को जला के उसमें छोड़ दो और इलेक्ट्रिक स्पार्क, and you will find a pop sound and you will get instantly there will be formation of water. So that is the condition. You are giving the required what we call activation energy that comes in kinetics chapter. So these are the different forms of Gibbs-Helmholtz equation that we shall derive when we blend first law with second law. So del G is equal to del H minus T del S के बदले में we write plus T del delta G by del T, because del S is equal to minus, so minus minus has become plus. The rate of change of delta G with respect to temperature. And if you just differentiate it, it will come minus del H by T square. And if you use from electrochemistry, this E is the EMF. Don't confuse with internal energy. Is the EMF of the cell. So del E by del T is called the temperature coefficient of EMF of a cell. As the temperature changes, the EMF also changes. So that rate of change of EMF of a cell with respect to temperature is called the temperature coefficient of the EMF of a particular cell, pressure remaining constant. So in place of del S, we have written this NF, because del S is equal to NF del E by del T. So we have written NF del E by del T. So minus sign is there. So T was there. So these are the different forms of Gibbs-Helmholtz equation, and its derivation we shall be, and this F is called Faraday constant. It is 96,500 Coulomb. And N is the number of electrons involved in the redox reaction, the N factor. So we'll be doing this in electrochemistry, and sometimes when you are handling problems from a very powerful source, which will not bother about whether you are a beginner or a revisioner, you come across, then you will not face any problem. So the word free associated with the free energy is a misnomer. It is not really free energy. That amount can be made free to the maximum extent. If you can extract delta Z naught amount of energy, you can extract, not more than that. It is not true energy, as it is not conserved. In reality, del G associated with a process represents the quantity of energy that is shared or spread related to change in the entropy of the universe. Because we have already seen del T del S universe minus is equal to del G system. Sethipai, instead of telling Gibbs energy, it should be better called Gibbs function, because it is not a true energy. It is a fake energy which is a device which is being introduced only for a bookkeeping prediction tool and to find the equilibrium constant. That is why it is not real. Its change is a handy tool to predict reactions and determine equilibrium constant. Eta karo. Now the numerical session comes. Don't write, leave some space, look from the screen and solve the problem, and leave some space, will write down there. So the enthalpy change del H is given for the entire reaction. So per mole is not written. It's the reaction. So del S entropy change at the standard state is plus 60 joules per Kelvin. Temperature is 298, 25 degrees Celsius means, and pressure 1 atmosphere. That has to remain constant for the Gibbs-Helmholtz equation to hold good. Calculate del G naught and predict whether it is spontaneous at that 25 degrees Celsius. If not, at what temperature it will be spontaneous? That means you first find the equilibrium temperature, where the two sides will remain together at midpoint. Find that equilibrium temperature and predict above that temperature or below that temperature, depending on the situation that you find, that del G will be negative. It is if positive, then for that you have to raise the temperature to write more than this equilibrium temperature, the reaction will be spontaneous. If you find del G is not negative. Susama Das, oh, you Bismay. Hi Bismay. What are you doing? So guys, you do calculate this, and I'm coming. You gaya, you aya. To grab something and fill my stomach, because you are not spending physical energy. Mental energy is also consuming some calories. Uh, you also order something from your kitchen. Your mom or anybody will be there, can help you. Hello?
Yes, sir.
You got the answer?
Yes, sir.
So will it happen? What is the delta G naught value?
Sir, 12,660.
Make it kilojoules.
Sir, 12.66 kilojoule. Sir, then it may be spontaneous at 509 Kelvin.
Above or below?
Sir, above.
At that, it will attain equilibrium at midpoint, right?
Yes, sir.
See guys, possibly we have done this mistake. Others, plus 30, either make it joule or make it kilojoule. Either of the two. So I am keeping it as kilojoule. I will be getting answer in kilojoule. So making it kilo, and minus T is 298 into del S. This is in joule, but I will make it 60 is 0.06, right? Kilojoule or more. So find out that, because this is kilojoule,
Sir,
this has to be in kilojoule. Ete bhalla.
sir, 12.66 kilojoule.
Omkar,
Yes, sir. 12.66.
Samita,
Yes, sir.
kete bhalla? How much?
12.6.
Since it is positive, you must write the reaction is non-spontaneous. At this moment, you will write this. Then you can find out equilibrium constant immediately is non-spontaneous. Then you have to find out the equilibrium temperature. So making del G naught is equal to 0, find the midpoint temperature. So midpoint temperature, equilibrium temperature is equal to del H naught by del S naught. That is equal to 50, sorry, 30.54 by 0.06. केते केल्विन आसला?
Sir, 509 Kelvin.
केल्विन रे आसीबो कारण एटी पर केल्विन देइछ एटी 60 जूल्स पर केल्विन, जूल जूल किलो जूल कटि जिवो, केल्विन रे आसीबो. सो 509 केल्विन रे 25 डिग्री माने 298 केल्विन रे हेई पारलानी सिना, किंतु जेहेतु एटा देखो एंडोथर्मिक प्रोसेस, एटे मार्क करो, एंडोथर्मिक प्रोसेस रे आमे देखिले लो टेम्परेचर रे बाहरुची डेल एस टा पॉजिटिव, सॉरी डेल जी नॉट टा पॉजिटिव, सो इक्विलिब्रियम कांस्टेंट टा नेगेटिव होउनी. इक्विलिब्रियम कांस्टेंट टा नेगेटिव कहूची कोन कहि थांती इक्विलिब्रियम कांस्टेंट टा की कहि परियो?
Sir, usually small.
स्मॉल माने केते कहा टू कम? लेस
1
देन
to
व्हाट?
2.
Yes,
Less
less
than
than
1.
1. Less than 0 के equilibrium constant है, less than 0 negative होगा नहीं. It will be less than 1. Maybe 10 to the minus 20. 10 to the minus 20 is not is a negative number. Still, it is a positive number. It will be very very small, less than 1. How will happen? কিন্তু the moment you increase the temperature, the equilibrium, the del G0 will be turning from positive value to negative value, and equilibrium constant will be turning from less than 1 to more than 1. So सेटा किंतु जेतेबेले 0 पकेइबो सेतेबेले इक्विलिब्रियम कांस्टेंट टा 1 बाहरिबो, एक्जाक्टली 1 बाहरिबो. एंड देखिबो सेटा होची 509 50 50. सो यू राइट above any temperature above 509 K, the equilibrium, the reaction is spontaneous. Write down the reaction is spontaneous. Bujila?
Yes, sir.
Yes, sir.
Omkar?
Yes,
Sami?
sir.
Sami Nani?
Yes, sir. Yes,
And
sir.
Phil Nani? Oh, Phil Nani. I was always reminded of that Phil Nani, who is now an engineer. He always posts me whenever he gets some prize or some felicitation, some job. She writes to me. Then I address her today as Phil Nani. She laughs. She smiles. She said, "Sir, आपन को जो क्लास रे तो फील ऐसे फील ता तो आसलानी आसुने मोटे हाई फाई सॉलिड स्टेट रे चलेली कला बेलको well guys, so those who are ignorant of what language I'm intermittently using, please don't worry, I will definitely access you in English. I'm trying to familiarize with my students here who are watching in Odisha and in this Zoom, who are mostly conversing in Odia bilingual. That's why. Yes, 509. Now, this is another question. Calculate del G naught for the reaction, the one I was talking of, del GF naught. Here you have to calculate from the free energy of formation values. Calcium carbonate, calcium oxide, carbon dioxide are given respectively this. Predict whether, for that entropy change is not needed. Whether it is possible at 298 K. If not, then at what temperature it will be spontaneous. And I am sure, you know, since it is a decomposition, it is an endothermic process, and for endothermic process, you will find in the next maybe next class, I really apprehend that we can go to the second program where we will correlate. That is what we call equilibrium thermodynamics. Because while we study equilibrium, it will be difficult to change the subject from equilibrium to thermodynamics. So therefore, I will spend some time to explain the basic concepts of equilibrium and equilibrium constant, Kp and Kc. Then we will be using in thermodynamics how to find out the equilibrium constant from del G naught. So do this, do this. Let me help you. This one, calcium carbonate solid on heating gives you calcium oxide solid and carbon dioxide gas. So this del Z R, this is the free energy change of this reaction is equal to sum of the free energy of formation F of products minus the sum of del Z of formation, free energy of formation of reactants. So that is equal to कैल्शियम ऑक्साइड का कितना, कैल्शियम ऑक्साइड का माइनस इज देयर हियर, minus 603.5 plus the other product is carbon dioxide का कितना, minus, that means it will be minus 137.2 minus, this is the product, minus, there is no coefficient 2 or 3, there had there been any coefficient would have multiplied. This is given in per mole basis. But if there are 2 moles, 3 moles in the equation, you have to multiply the coefficient. Minus calcium carbonate ka kitna? It is again minus 1128, all in kilojoules. So what is the result?
So 388, positive 388.
Positive 388 kilojoules. So since it is positive, del G naught is positive, it is definitely a impossible or say a left favored reaction, non-spontaneous reaction. So what is the equilibrium temperature? Just the previous case you find out it is non-spontaneous at because the data given is at standard state. All these data are given in standard state. It's understood. Non-spontaneous reaction at 298. Then find out what is the equilibrium temperature, which is equal to del H by del S. That you can't find out. That you can't find out unless you no you have to I have added this. How can you find the equilibrium temperature? Only from del G naught data. Del G naught data is found out from del H, del S and T. So unless we know del H and del S, we can't find. So this will not be possible to calculate from only del G
Sir,
naught data. Yes.
sir, but we can qualitatively say that at more than this, more than 298.
More than, but how many more? This will be a vague answer. At
Yes,
what
sir.
temperature? It may not be at 300, it may not be at 305. जैसे कि हमने देखे थे last time 509. So we don't know. It is so high, plus 388 is so high that we don't know at what temperature it will become 0, and then after that del G naught will be negative, and hence it will be a spontaneous process. So I am definitely deleting this. Okay, you got it?
Yes, sir.
This one is a very interesting one. Very simple and interesting. You can do it. Don't be frightened or you don't sigh away, or don't be scared with this bulk of this problem. I'm reading out reaction H2G plus half O2G giving you water. I told you it is an impossible reaction at ordinary condition, but this is used in the fuel cells. Nowadays, hydrogen oxygen fuel cells are used in rocket fuels and many other, even hydrogen trucks are available using hydrogen oxygen fuel cell. In US, so many trucks are flying, although it's not doing good market. The EVs are doing good market, particularly the Tesla company has pioneered in EVs based on lithium ion battery. But hydrogen oxygen fuel cells are also on the automobile sector, but it's not been 100% successful. The reaction, this is used in fuel cells to produce electric current, and this del HF, heat of formation of water, the same principle, right minus left, can be found out for any enthalpy change of the reaction by adding all the heat of formations, enthalpy of formations of the right side minus enthalpy of formation of the left side. The enthalpy change of this reaction is minus 285. Enthalpy change, it's not because this is the heat of formation equation. This equation is heat of formation equation. So the enthalpy change of the reaction is nothing but the enthalpy change of formation. So nothing to worry. That means delta H is given. The reaction can be carried out by direct combustion. Just put a glowing matchstick, it will have a pop sound and it will immediately react. And that means this amount of energy will be all evolved. We are not carrying out any non-expansion work. All this will be evolved. The reaction can be carried out by direct combustion. The entropy data is given. Oxygen is at this much, hydrogen this much, water this much. It's sufficient to find the amount of heat released when reaction takes place by direct combustion. Direct combustion is already, there is no entropy data is required. But for B, entropy data will be required. The amount of electrical work the same reaction can perform in the fuel cell at 298 K under reversible conditions. The amount of heat released, so definitely it is wanting delta Z. Delta G naught amount of heat that it will generate will be used up in performing the electrical work. So first of all, find out delta S, then del H is given, use the Helmholtz equation to find del G, and say that this amount of kilojoules will be used for electrical work done, V into Q, that is you will know subsequently NF, Faraday constant, the number of electrons, that is the N factor, into the EMF of the cell. But in principle, potential difference, which is E, there we take E, you take V of the cell, into the total charge is NF. For 1 mole of electrons, it is 1 Faraday charge, and for n moles, it is n Faraday. So NF into V, that is E. That is the change in free energy. That is the decrease in free energy. So we will be doing that. But you find out this from this given data. Now, let me help you, del G, find out direct combustion, same. No need direct combustion, we will get this as heat. Minus 285.9 kilojoules per mole will be the amount of heat released when reaction takes place in direct combustion. Then what will happen to that heat if you have a gaseous system somewhere? That heat will be used for expansion. It will do expansion and the surrounding. We forget about it. What happens to that heat? It will all be released as heat. And in the second one, when you are getting a electrical work done, which is a non-expansion, so you have to use Gibbs Helmholtz equation. For that, we have to find out del S is equal to right minus left. Right is water. Water free energy, entropy, absolute entropy is 70, minus hydrogen is 130.6, plus half into oxygen. Oxygen is 205. Half into 205. This half mole is there. So what is the total entropy change in joules per Kelvin per mole? Kete pailo? How much you got?
Then minus 163.1.
Minus 163.1. Then you use this del G0 is equal to minus 258.9 minus T is 298, saying at 298 Kelvin into minus 163.1. So as you know, when del H is negative and del S is negative, then at higher
So,
temperature it will become.
so,
So what is?
so del H is 285.9.
Oh yes, I'm so sorry. Not 258. This is 285. 285.9. I'm so sorry. So what is the total del G you are getting? Totals, I'm sorry. What is the del G you are getting? Omkar, are you tired? Are you retired? Omkar?
No, sir.
Sir,
Which retired?
48.317
48,000.
kilojoule. 48.31 kilojoule.
So make it kilojoule.
Yes, sir.
Yes,
48.31
sir.
Because these are in
kilojoules.
48.31
kilojoules.
kilojoule.
So make this delta S as kilo. I'm so sorry. This will be point, right? I have made a mistake here. You didn't point out. You are pointing out all other mistakes, but you are not pointing out this is in joules per Kelvin per mole. So make it kilojoule. But this is this delta H is kilojoules. This is kilojoules. So this is joules. So this is minus 298 into minus 0.1631. ଏଇଠି କ'ଣ ଗୋଟେ ଗଣ୍ଡଗୋଳିଆ କରିଥିଲି ଏଠି ଏତେ କାହିଁ କଲି ଏଇଠି ତ 298 ଥିଲା minus 298 into minus 0.163. केते आसला
sir, minus 2.37 kilojoule.
ठीक
Sorry,
आसला
sir. No, sir. Minus 237.2 kilojoule.
ठीक आसला ओमकार सो डेल जी नॉट
Yes, sir.
बाहरला -237
296.
एतिकी किलोजूल्स यूज ହେଇଛି for out of numerically out of 285.9 I am talking of numerically यूज ହେଇଛି ବାହାରି ଯାଇଛି ବୋଲି ସେଥିପାଇଁ କୁହା ହଉଛି out of 285.9 kilojoules per mole of water formation per mole of water that has been produced out of which ଏତିକି that would have been produced had it been direct combustion out of that only ଏତିକି amount of 237.29 kilojoules would be maximum extracted for electrical work and the remaining କେତେ ବାହାରକୁ ଯାଇଛି heat third ରେ how much of heat released so the heat released ts energy is equal to minus 285.9 minus 237.29 released का मतलब definitely negative रहेगा तो how much negative released का मतलब
Sir,
एक्सोथर्मिक नेगेटिव रहेगा कितना अरे
Minus 48.7.
yes so out of the 285.9 that would have otherwise been evolved had there been a direct combustion if we use it for the purpose of non expansion compression work electrical work then maximum out of 25 it can take 237.2 so since minus is because it is evolving that the it is producing that heat to perform work electrical work the heat is being produced during that reaction so heat is negative means the work will be positive it will be doing unto us so it will be doing unto us so it will be the electrical work done is the decrease in free energy. So the work done will be also negative because del G is negative means in this case work done is negative because work is done by the fuel cell by the system. It's not expansion compression work. We shall see later del G that is the work done is the decrease in the free energy electrical work done. So W is equal to decrease in free energy minus del G is equal to minus NF. That we shall study in our electrochemistry program. So del G naught. So हमें क्वेश्चन टा कर देले सॉल्यूशन टा मध्य से आछि ओइटी सॉल्यूशन टा कर देइथिली से आछि एटा गोटे घरे करिवो एटा आराम रे कर दे परिवो एटा del HF डेटा दिया हिच थर्मोडायनामिक्स टेबल रु तमे del HF डेटा नबो ए आरो तारो सो राइट माइनस लेफ्ट करके del H बाहर करिवो एंट्रोपी डेटा से देइछि तळे से टेबल रु देइ देइछि हीट ऑफ फॉर्मेशन ऑफ इंडिविजुअल आर जीरो देइथिबो आर जीरो देइथिबो नहीं जीरो सॉरी क्लोरीन रो जीरो देइथिबो काई क्लोरीन एंट्रोपी नुए देइनी माने जीरो सो एलिमेंट मानकर इन स्टैंडर्ड स्टेट रे क्लोरीन इज ए गैस क्लोरीन लिक्विड होता लिक्विड को गैस करने दे लैटेंट हीट ऑफ वेपराइजेशन ऐड होता से एक्स्ट्रा नहीं था किंतु नेटिव स्टेट रे जदि हीट ऑफ फॉर्मेशन हो कि एंथैल्पी फ्री एनर्जी ऑफ फॉर्मेशन जीरो सो राइट माइनस लेफ्ट करी डेल एच बाहर करिवो एवं डेल एच टा इंडिविजुअल एंट्रोपी देछि राइट माइनस लेफ्ट करी बाहर करिवो एटा हीट ऑफ फॉर्मेशन यूज करी राइट माइनस लेफ्ट करी बाहर करिवो एटा इंडिविजुअल एंट्रोपी राइट माइनस लेफ्ट करी बाहर करिवो तापरे डेल डेल जी नॉट हेल गिब्स हेल्महोल्ट्ज इक्वेशन यूज करी मैं पचारिबो बाहर करिवो 127 डिग्री सेल्सियस रे रिएक्शन टा स्पॉन्टेनियस की टीटा पकेबो 273 प्लस 127 इफ नॉट जना पड़ुची इफ नॉट at what temperature or above which temperature or below which temperature the reaction will be spontaneous. Also calculate the temperature at which reaction reaches এটা তো আগে করিব তবে also find the equilibrium constant এবে বাহার করি পারিবনি এবে তো আমি বাহার করি পারিবনি এটা এটা দেইছি এই যে 55.75 টা ডেল জি নট आंसर তো দেইছি তখন ডেফিনেটলি কেসি র কে ইকুইলিব্রিয়াম কনস্ট্যান্ট কেপি র ভ্যালু বাড়িব ইজ লেস দ্যান 1 10 to the minus hugely minus 10 to the minus something right এটা ঘরে করিব এটা भी ঘরে করিব आराम रे करि परिबो so shall we go to the thermodynamics equilibrium ना काली करिया
Kali.
Let's go, sir.
हां
Correct, sir. Sir,
ओमकार
एबे
को
करी.
जी ओमकार को जी काली करिया ओमकार तुम टिके ये करो मो जॉगिंग फॉगिंग करो कि जिम करो এবং अंडा डेली দুইটা লেখা খাও take 2 eggs boiled eggs every day but for that you have to go for a very rigorous exercise games खेलो जाएंगे कोठी आउटडोर गेम
Yes, sir, I play football.
good and keep the regularity at least 2 to 3 times a week खेलो even girls मन को मध्य कहे तुम्हें खेलो किछि नछि सानो भौणी जदि अछि ता संगे गोडा गोडी खेलो जेमति you exhaust yourself you heavily sweat and that will give you a lot of mental faculty improved you will see खेलिबार केते मु बारंबार रुद्र को भी सेया कहूची तो अपा संगे घोड़ा गोड़ी खेल बाहर जाए कहूँ से लाज इटा से जीवनी बाहर को अच्छा नाउ तुमको unless you keep patience interesting जिनसे करि परिबनी नहीं this is thermodynamics of equilibrium देखो मु गोटे and very happy to find that some viewers are still watching and some have left doesn't matter I am producing this video I mean I'm having these classes basically for you and but I have kept it for public if by chance some of the guys after me will can benefit right देखो मुझे छोटे पेज नहीं let me first make you understand what is equilibrium so every reaction A plus B every reaction comes to a halt means there will be no more reaction but that halt is not a static halt the forward reaction and backward reaction they will be taking place at the same rate so that it appears as if nothing is happening so that stage is called equilibrium stage that happens to every reaction for irreversible reaction you know the reaction is almost 99.99% complete we say it is irreversible but virtually practically it becomes irreversible but in principle all are reversible but in practice many become irreversible because their del G naught is so very highly positive so very highly negative that equilibrium constant that we shall find out now is far greater than 10 to the power 5, 10 to the power 10, so that they become virtually complete. आउ जो माने मिड पॉइंट रहिबो इक्विलिब्रियम कांस्टेंट 1 डेल जी नॉट टा 0 हबो आउ जहार डेल जी नॉट टा पॉजिटिव हबो से मिड पॉइंट रु लेफ्ट रहिबो जेते जेते पाखु को जीवो 0 रो पॉजिटिव रु प्लस 10 टू द पावर 10 10 टू द पावर 5 10 टू द पावर 2 10 50 10 10 2 1 प्लस रे अछि से क्लोज को जीवो 1 को मिड पॉइंट को सो जानिबा पई इक्विलिब्रियम आसिला परे रिएक्शन टा स्टॉप हैला परे इक्विलिब्रियम कांस्टेंट केते कोन धर यार कोएफिशिएंट अछि ए यार बैलेंस इक्वेशन यार बी यार सी यार डी स्मॉल लेटर्स इक्विलिब्रियम कांस्टेंट इज इक्वल टू concentration of C to the power C into concentration of D to the power D माने प्रोडक्ट टा रहिला न्यूमरेटर रे और रिएक्टेंट टा रहिला डिनोमिनेटर रे एंड द कोएफिशिएंट्स विल अपीयर एज पावर ए केमिति हला परवर्ती काल रे आमे डिस्कशन करिबा खाली एति की जानि रख वर्तमान ता डिटेल्स को आमे जीवानी एटा हला केसी एक्चुअली आमे जोटा डेल जी नॉट रु भारिबा सेटा होची केपी दैट इज पार्शियल प्रेशर ऑफ C टू द पावर C यदि गैसियस हेथिबो partial pressure of D to the power D by partial pressure of A to the power A into partial pressure of B to the power B. So सब गुड़ा को gaseous हेथिबो आउ एमती रिएक्शन हेथिबो गोटे सॉलिड थिबो कि लिक्विड थिबो आउ अन्य गुड़ा गैस हेथिबो से केस रे तार प्रेशर नाही आउ कंसंट्रेशन ता चेंज हुएनी प्योर सॉलिड और प्योर लिक्विड मानकर कंसंट्रेशन चेंज हुएनी because तार वॉल्यूम कमे नंबर ऑफ मोल्स कमे so number of moles per volume unit volume n by v that remains constant so they are out of the expression of kp and kc so solid and liquid जोट थिबो गोटे गैस थिबो kp होची खाली सेही प्रेशर पार्शियल वर्ड टा यूज करि होबनी सेही प्रेशर टा जदी राइट्स रे थिबो सेही प्रेशर रो टू द पावर समथिंग जदी कोएफिशिएंट थिबो तो तळे थिबो 1 by something solid and liquid they are not represented in the Kc Kp expression so dita अछि eta होची with respect to concentration eta होची with respect to partial pressure if equilibrium जहां भी हो ए दीटा देखो कॉमनली कहते इक्विलिब्रियम कांस्टेंट इफ के इक्विलिब्रियम कांस्टेंट इज 1 ता माने प्रोडक्ट रो गुणफल वर्ष आमु कहतली इज इक्वल टू 1 कहला माने प्रोडक्ट इज हाफ हाफ किंतु कहि होबनी कारण जदी कोएफिशिएंट अलग अलग थिबा 2 और 1 और 3 सो माने प्रोडक्ट रो कंसंट्रेशन रो गुणफल संगे रिएक्टेंट रो कंसंट्रेशन गुणफल समान नाउ वी अंडरस्टैंड द रियल मीनिंग सो इक्विलिब्रियम 1 हेले मिड पॉइंट को आसीबो जा को हमें कहउछु तेणु जदी इक्विलिब्रियम इट इज मिड पॉइंट हमें ताकू कहि दबा इक्विलिब्रियम कांस्टेंट जदी ग्रेटर देन 1 हुए राइट फेवर्ड जेते जेते अधिक हबो सेते सेते राइट फेवर्ड एंड इक्विलिब्रियम कांस्टेंट ता लेस देन 1 हेले ताले डिनोमिनेटर अधिका न्यूमरेटर कम त माने लेफ्ट फेवर्ड बुझिलो रेज योर हैंड्स तो बुझले कि नहीं समिधा तुमरा मुंडरे अछि त भितरे पसुची
Yes, sir.
सो सिंपली केपी केसी रो एक्सप्रेशन होची कोन ना ऊपर रहिबा प्रोडक्ट इक्विलिब्रियम आसला परे थर्मोडायनामिक्स संग रिलेटेड रेट किते शीघ्र इक्विलिब्रियम आसला हाउ फास्ट द इक्विलिब्रियम कम्स हाउ स्लो द इक्विलिब्रियम कम्स डजंट बदर because chemical equilibrium comes under thermodynamics not comes under kinetics so after the attainment of equilibrium reactant ro concentration रहिला तळे product ro concentration रहिला ऊपरे and the coefficients are coming as power of the relative of the respective concentration or partial pressure now see interesting jinsa dekho गोटे term I will introduce a term called del G. So far we have been doing at a constant temperature and pressure and giving that constant temperature and pressure as standard state giving a not symbol to everything. Now I will be introducing, while not is there, I will be introducing another term del G, which is a variable term. We shall start begin a reaction. मैं तीनों लैंग्वेज में आपको समझाना चाहूंगा, इंग्लिश, हिंदी, as well as in Odia. Del G, actually it is not del G, actually it is a slope of the graph at a particular point. It is dg by d xi. Xi is the reaction coordinate. That means it is time. In physics, we call time as the progress of reaction. So dg by dt, how it changes with time, as the graph will be falling down negative, less and less negative. Finally, when this will flatten, the slope will become 0. We call del G is equal to 0. At that time, the reaction attains equilibrium. Now, this del G0, which we calculated based on the Gibbs-Helmholtz equation, is for the 100% conversion of the reactant to product. We took the heat of formation of the products minus heat of formation of the reactant, find del H and del S, then del G naught, or directly del G naught. That means 100% completion, which never happens, which in principle never ever happens. It may go towards 100% and 99.99%, but not 100%. It may also take place 1%. It may also occur 40%. It may occur also 60% when equilibrium will come, and there will be no further movement to the right or left. So when you start a reaction, then you have to see how far we can go, when the equilibrium will reach. It's not del G naught is equal to 0. Del G naught is something different from del G. Del G is really this. We take it as del G, which confuses us. Del G can also be in another condition, the whole reaction. But here we are taking del G as a variable which is changing from a highest value till 0. Once it becomes 0, the reaction attains equilibrium. Del G cannot be positive, cannot be positive. It's not the del G that we learned. Therefore, it is better for you guys, it is better to say that it is dg by dg upon dxi at constant temperature. Now see what happens here. Del H and del S, they are not very much, dependent on temperature. They do not change if the temperature variation is narrow. But undoubtedly del H will change. We shall be doing the Kirchhoff's equation to show how del H also for a particular reaction changes when temperature variation is very high. So also del S. But del G is highly responsive to temperature. Therefore, if you change the temperature, we keep del H naught and del S naught fixed. But recalculate del G naught, what will happen? Because del G naught is highly temperature sensitive, while del H naught and del S naught are not. So what I was saying, the del G that now I am talking of is not really del G naught that we are talking of. Now I am giving you this variation equation called the Van 't Hoff's isotherm, that del G, that is the variable del G, when this del G will be coming from the highest value, then most negative value, and the slope numerically will reduce, and finally the slope becomes equal to 0, that it will be parallel to the x-axis, and that time this Q, as you find, becomes Kc. What is Q? Q is called the reaction quotient. That continues to vary till equilibrium is reached. Once, and Q is same as the expression for equilibrium constant. Equilibrium constant, whatever is the expression, Q, what is called the reaction quotient, the expression is exactly same, but that is in the non-equilibrium condition. When the equilibrium has not reached, you don't say it is Kc. The ratio is not called K equilibrium, it is called Q. The moment equilibrium comes, when this slope vanishes, del G becomes equal to 0, the so-called del G becomes 0, then this Q will become K equilibrium, and that too it is Kp. This is called Van 't Hoff's isotherm, which has originally derived from the chemical potential. So I'm not going to the details how this equation has come, but you have to write this equation. Write down Van 't Hoff's isotherm. Del G, which is really dg by dxi P is equal to del G naught plus RT ln Q, where del G or dxi by as a dg by dxi, they are variable till it becomes 0. And del G0 is constant for total conversion. That value so far you have been finding out in del G naught for the total conversion, which never happens, which is fixed, which is given in the literature. Literature नदेइथिले भी, if you are having the literature, the free energy, standard free energy of formation, from that you can find out right minus left करके you can find out what is del G naught of the reaction that is in question. Short at 6:30 and you are up to 9:40. 3 hours, 10 minutes. It's not a joke. It's not a joke. I think we shall be beating the which record? कौन था कहते कि record?
Sir, Guinness Book of World
Guinness
Records.
Book record. Yeah, because you know school guys like you, class 12, continuously in a particular subject. Oh, you go for one class to the other class. There is a chit chat. There is a break and there is a relaxation. But in one topic, you are listening to me and I am talking to you for more than 3 hours. 3 hours, 11 minutes. It's not a joke. We have crossed all Guinness Book record, perhaps. So, Samita, are you, after this much of encouragement, motivation, are you still feeling fatigued?
Sir, I'm feeling,
but somehow I have to do. क्या करेंगे? I understand what you say. Therefore, I will continue. What to do? You are not leaving us. What to do? Okay. While Q is called reaction quotient, which is variable till equilibrium, and this equilibrium constant you have already written, right? Now write down once again. Q is same, write down, but in non-equilibrium condition. Once on 10 minutes more, I'll just show you the graphs and tell you the exact concept, which perhaps you will not find in your books. They have totally messed up with del G, which is variable del G, and del G, which is constant del G for 1 mole or for the entire reaction, which is an extensive property. If there is no 1 mole, then per mole is not written. Only values are written. If by chance there is a formation of 1 mole or 1 mole is involved, then per mole can be written. It's an extensive property, del G. And this del G is something different, is variable del G. Totally messed up. This is the root of everything, that is Van 't Hoff's. And how it came, I will not explain to that. That is del G, which is variable, is equal to del G naught plus RT ln Q. Have you written down?
Yes, sir.
Yes, sir.
Any question, Rudra?
No, sir.
Let us not bother now for the moment. Who are watching or will not watch for 3 hours, they will be fed up. Let them be fed up. I told them they the viewers should watch, on a systematic basis. Supposing 1 hour today, 1 hour next day, 1 hour third day. It's not possible to watch for 3 hours at a stretch. Not all like Omkar and Rudra. And of course, Samidha is also struggling. She is also giving the good competition. Now see the interesting aspect. This is the first case where del G naught is negative. This is the absolute free energy of the product. This is the absolute free energy of the reactant, which cannot be found out. But del G is negative. The whole reaction as a whole, del G naught is negative because the product level is much below. The more the product level is below than the reactant level, del G is more and more negative, and you will find equilibrium constant will be more and more greater than 1. So the del G is less than 0, but this del G is this one. This, if you draw a parallel line from there is a minimum point after which it goes up. So if you draw a parallel line, so this displacement, this gap is called the so-called del G, which is actually the slope of the tangent at any point of this curve. So that we call del G, that gradually numerically decreasing, and finally this becomes del G becomes equal to 0. That means the slope will vanish and the slope will become 0, as this will be parallel. Then equilibrium will come. EQ means equilibrium will come. There will be no more reaction. So in such a situation, the minimum point comes very, very close to the product side. Undoubtedly, the more this reactant side is above than the product side, the minimum point comes very, very closer to the product side, and you will find after some time the equilibrium constant will be high. This Xi is the composition. In fact, I told you the time, but actually it is composition, which is also related to time, but it is actually composition Xi. That means the composition R is the reactant. I'm taking a single reactant for explanation, single product. So in this way, the reactant concentration is decreasing, product concentration is increasing. So greater is the delta G. Numerically, the more the negative value, more the gap, more is the product formation, because the minimum point comes closer to the product side. Look to delta G positive, second case, where the reactant level is lower than the product level, so that the minimum point comes closer to the reactant side. So this much only but reaction happens up to this point. Up to this point, reaction happens. Del G naught is positive. But this variable del G, so-called del G, that is actually dG by dxi, it also goes on decreasing and becomes equal to 0 at this stage. Reaction stops after maybe 1%, after maybe 0.001% of the reaction stops. That so-called del G or dG by dxi becomes equal to 0 slope, and there will be no further movement. And in this case, del G naught is equal to 0. That means reactant and product have the same height, same level of energy. So del G, there is no difference. Del G naught is equal to 0. So in this case, ohm, have a look. Ohm, when del G naught is equal to 0, the minimum point comes at exactly at the middle, so that is equilibrium constant will be equal to 1. Here equilibrium constant is less than 1. Equilibrium constant is greater than 1. Please draw these graphs. They are very important. And we'll go. We will not solve any problem, because once we understood, if we don't write down, then we have to start fresh. tomorrow. Can we sit tomorrow? Because that girl faces
Yes,
a
sir.
problem. But let us sit tomorrow. The girl will watch the video. She is very passionate about learning. She has a good IQ, but unfortunately she can't devote time. Doesn't matter. कुछ पाने के लिए कुछ खोना पड़ता है. So we have to compromise. I told you that this group is for those who are advanced level aspirants. Advanced level means IIT advanced level aspirants. If at all someone is neat minded, he has to be passionate about study.
Sir,
Hmm.
sir, actually, काली भी मैं बस पर भी नहीं.
Okay, you watch later. ठीक है?
Yes.
Okay. If you now want to leave, you can leave. Do you want?
Sir, एमबी आप कितने समय पे चलेंगे?
ଆଉ 10 ମିନିଟ୍ କହି ହବନି 10 ମିନିଟ୍ 10 ମିନିଟ୍ ଲାଗୁଛି ମତେ.
Sir, ମୁଁ
It is
leave
now.
କରିଦେଲି
ହଉ
and
leave
dinner
କରି
time ବି ହେଲାଣି ଏବେ ଆମର.
ହଁ. You go and take the dinner and leave the class and last ଯେତିକି minutes ଥିବ ବର୍ତ୍ତମାନ ହେଲାଣି 3 ଘଣ୍ଟା 19 ମିନିଟ୍ 3 ଘଣ୍ଟା 19 ମିନିଟ୍ ପରେ ଦେଖିବ ଆଉ କଣ ହେଲା.
Yes, sir.
Bye.
Thank you.
ଡ୍ର କଲ?
Sir, ଗୋଟେ ହେଇଛି.
ନାଇଁ କର ମୁଁ
ଗୋଟେ
ଅଛି.
ବାକି.
କିଛି ନାହିଁ ତମେ ଦି ଜଣ ଥିଲେ. I am not at all worried for anyone. So so-called del G is a variable del G and becomes 0 for all types where del G naught is positive, del G naught is negative, del G naught is equal to 0. It is valid for all. So this del G, which is a variable del G, is actually not del G. It is the slope that is changing. ତାକୁ ବହୁତ ବହିରେ del G ବୋଲି କହୁଛନ୍ତି. That is the slope. ହେଲା?
ହଁ ସାର୍ ହେଇଗଲା.
ମୁଁ ଆଜି ଯେମିତି ହେଲେ ଇକ୍ୱିଲିବ୍ରିୟମ୍
Done,
କନଷ୍ଟାଣ୍ଟ
sir.
ବାହାର କରିବି. ଇକ୍ୱିଲିବ୍ରିୟମ୍ କନଷ୍ଟାଣ୍ଟ ବାହାର କରିକି ଛାଡ଼ିବି. ସେଇ ଗ୍ରାଫଟା ଆଉ ଗୋଟେ ସୋର୍ସରୁ କପି ପେଷ୍ଟ କରିଥିଲି. ସେଇ ଗ୍ରାଫଟା ଦେଖ ଏଇଠି ଆସିଗଲା. ସେଇ ଜିନିଷ ରିପିଟେସନ ଲେଖିବା ଦରକାର ନାହିଁ. del G, this del G is actually dg by dxi. ଏଇଟା is a variable del G. ଏଇଟା del G d not so far ଆମେ ଖାଲି ଯେତେବେଳେ ଖାଲି del G ଲେଖିଥିଲେ we meant complete conversion, which is del G not RT ln Q. ଆଉ ଯେତେବେଳେ del G ଟା 0 ହେଇଯିବ ଏଇଠି ସେତେବେଳେ Q ଟା ହେଇଯିବ K equilibrium. So এইটা লেখো, এই particularly এইটা লেখো, এইଠୁ লেখো, এইটা লেখো del G is equal to del G not. এইটি फिर भी ब्रैकेट रे लिखि देइथाओ एक्चुअली dg sorry ja is the composition, change in composition. It actually del G naught plus RT ln Q. It is the Van 't Hoff isothermal ଆସିଛି. ଆଉ ଏଇ ଯୋଉ del G ଯେତେବେଳେ 0 ହେଇଯିବ ସେତେବେଳେ Q ଜାଗାରେ ଆମେ ପୁଟ୍ କରିବା କଣ ନା ଇକ୍ୱିଲିବ୍ରିୟମ୍ କନଷ୍ଟାଣ୍ଟ, and that is Kp by default. ଆଉ ଯଦି କେହି ଗ୍ୟାସ୍ ନଥିବ, ସବୁ ସଲ୍ୟୁସନ ଥିବ, ସଲିଡ ସଲ୍ୟୁସନ ଲିକ୍ୱିଡ ଥିବ, ତାହେଲେ Kp is equal to Kc ଆମେ ପରେ ପଢିବା. ସେ କେସରେ Kc ବି ନେଇ ଯାଇ ପାରିବ, କିଛି ପ୍ରୋବ୍ଲେମ ନାହିଁ. Kp ର ଅର୍ଥ କିଛି ନାହିଁ କାରଣ no gas no pressure by default it is Kp. କାରଣ ସେଟା ଗ୍ୟାସ୍ କନସେପ୍ଟରୁ ହିଁ ଆସିଛି, କେମିକାଲ ପୋଟେନସିଆଲଟା ଗ୍ୟାସ୍ କନସେପ୍ଟରୁ ହିଁ ଆସିଛି. जोटा मु कहूनी कोठु सेटा एनालिसिस हेछि भेंट आइसोथर्म टा देखिलो
Yes, sir.
Yes, sir.
नाउ कोन हे गला जब 0 पुट कर दबो कोन हे गला सु एटा जब 0 हे गला एटा जब 0 हे गला सो del g not is equal to minus rt ln q del g not is equal to minus rt ln q that is equal to minus 2.303 rt log kq और ताकू जदि आमे करिवा k equilibrium constant is equal to e to the power minus del g naught by rt ln अनुसार बेस ता तो e अछि e to the power minus del g naught by rt this is another expression using the Euler constant e so 8 देखो इंटरेस्टिंग जिंस देखो एटा पूरा मैथमेटिकल टोटल मैथमेटिकल ठीक देखो आगो del g naught ता नेगेटिव हबो सेते बेले इक्विलिब्रियम कांस्टेंट ता कोन हबो del g टा नेगेटिव माने नेगेटिव नेगेटिव पॉजिटिव हे गला पॉजिटिव है कि इक्विलिब्रियम कांस्टेंट ता डेफिनेटली ग्रेटर देन 1 हबो del g टा तो ग्रेटर देन 0 पॉजिटिव हबो ताहले एई नेगेटिव टा रहिला इक्विलिब्रियम टा रहिला माने ए जो 10 तो इक्विलिब्रियम कांस्टेंट बाहर करिवो e टू द पावर हो कि 10 टू द पावर हो ए 10 टू द पावर माइनस समथिंग को पळेबो ए माइनस टा एज ए पावर को पळेबो कारण log एटी अछि ln अछि तो del g नॉट टा पॉजिटिव हेले इक्विलिब्रियम कांस्टेंट टा नेगेटिव होबनी इट विल बी लेस देन 1 10 टू द पावर 0 टा होची 1 10 टू द पावर लेस देन 0 नेगेटिव क्वांटिटी टा होची पावर टा जदि नेगेटिव होबो इट विल बी लेस देन 1 तुम कोन कहूची तुम तो अंक रे आनिचो मास्टरी योर मास्टरपीस इन एंड del g नॉट तो 0 होबो देखो del g नॉट तो 0 होई जीवो तले कोन कोन टा ln 1 टा ही 0 बा log 1 टा 0 तमन इक्विलिब्रियम कांस्टेंट टा 1 होबो जदि del g नॉट टा 0 होबो एथरु जणा पड़ी जाउची होबो एंड देखो बाय डिफॉल्ट k इक्विलिब्रियम टा होची kp विथ gaseous component present so ताकू जदि एपट सेपट करबा del g नॉट जगह रे गिब्स हेल्महोल्ट्ज इक्वेशन पुट करबा del h minus t del s is equal to rt ln k एवं del g नॉट टा को भूली जिबा establish relationship between enthalpy change entropy change ln k को गोटे पट को आनिबा अन्य पट को अन्य जिंस नबा so it will be and minus गुणी देकरी ln k टा को पॉजिटिव कर दबा ए आर पट को नै जिबा ए डेल्टा s टर्म टा पॉजिटिव हे जिवो r रे सब डिवाइड कर दबा then del s naught by r minus del h naught by rt so 1 by rt जदि हबो गोटे इंडिपेंडेंट वेरिएबल and the slope will be equal to minus del h naught by r and the intercept will be del s naught by r right and that is when del h naught is positive when endothermic reaction is there then the slope will be negative but once del h is negative that means it is a exothermic reaction minus minus will be positive the slope will be positive so this is for endothermic write down are you understanding guys
Yes, sir.
ओमकार
Yes, yes, sir. Yes, sir.
भोक हेले मम्मी को कुह खाइबा को देबे कोन टिके सेठी
ना 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 सर एकाथर खाइया
ओ खाया मु भी ब्रेकफास्ट करनी मजरे टिके जाइकरी I grabbed some fruits but taken bad thing tea 2 times which the kids should not so tome kid hi ke na आउ but we consider you as kids now हाँ लिखि दियो एटा देखि दियो then only आमे का गोटे इक्विलिब्रियम कांस्टेंट बाहर करी के पळेबा as look at this in mathematical terms
Done, sir.
mathematical हेगला
Yes, sir.
Yes, sir.
and then if it is exothermic I have drawn the graph here you'll find if it is exothermic del h टा negative hobo ताहले there will be positive slope even sometimes you'll find in problem this slope can go down, so it can be a negative intercept also, where there is entropy change will be negative. It is because from the intercept you find the entropy change. If it will remain positive, then entropy change is positive. It remains to the negative y-axis, then entropy change is negative. And this x-axis is 1 upon t. So I have given you a problem to find out entropy change, enthalpy change from the graph. I think I should maintain restraint to leave you at certain point of time. Eta draw kar diyo. And if you take two different temperatures, one is at T1, the other one is at T2, and presuming that del H naught and del S naught remain constant during a small temperature range, it is not changing. T1 and T2, they are changing temperatures, but during that change, del H naught and del S naught are not changing. Then if you can subtract ln ln K2 minus ln K1, that will become ln K2 by K1, and you subtract the del S naught by R will cancel out, and T1 term will come up. Taking del S naught by R common, you will find 1 by T1 minus 1 by T2. This is called the Van 't Hoff's equation to find out the equilibrium constant at certain temperature. If the equilibrium constant at some other temperature is known and the enthalpy change of the reaction is known. Is it clear to you?
Yes, sir.
These are all mathematics. Well, it's calculation, not mathematics. Calculation. If one is little familiar with calculation, you will know del S naught by R term will cancel out. Then that will become plus. So T1 term will come ahead of T2 term. And you are subtracting ln K2 minus ln K1. So that becomes ln K2 by K1. So this
Yes, sir.
is
Yes.
learning. Done.
Yes, sir. Yes, sir.
Itte sigra. So soon. ତମେ ଡର ନାହିଁ ମୋ ଯେତେବେଳେ ଇଚ୍ଛା ହଉଛି ଓଡ଼ିଆରେ ପଚାରିକୁ ପଚାର. We are not shying away from our language. ନହେଲେ feel
Yes,
ଆସିବନି.
sir.
Yes, sir.
Okay, so now mathematically you tell me. You tell me, supposing del H is positive and you are handling, look to this equation, you are handling an endothermic reaction. If del H is positive, what will happen if T2 is always a higher temperature than T1? T1 is a lower temperature, T2 is a higher temperature. So consider that T1 as a lower temperature, T2 as higher temperature. So what will happen to the equilibrium constant? K2 is at T2 higher temperature, and K1 is at a lower temperature. So what will happen to the equilibrium constant when temperature is increased if the reaction is endothermic?
Sir, it will also increase. K will also increase.
Yes.
Sorry.
Since T1 is lower than T2, then definitely
Sir.
1 by T1 minus 1 by T2 will be greater than 1. Greater than, greater than, as T2 is more, so T2 will come here, minus T1 will come here. So this term will be positive. Yes or no?
Yes, sir.
And
Yes,
del S
sir.
naught is positive. So ln K2 by K1 will be greater than 1. That means definitely jaha kale bhi K2 will be greater than K1. Yes or no?
Yes, sir.
Yes, sir.
So for endothermic reaction, if the temperature is increased, if the fixed temperature is increased, then the equilibrium constant will be increased, more product will be formed. You understand? It likhi deji mu.
Yes, sir.
It likhi deji, dekho, del H is positive, equilibrium constant increases with temperature. If del H is negative, you are handling an exothermic reaction. Then if such a reaction, if you increase the temperature, then this is always positive and this is negative, so that it will be negative. So K2 10 to the power minus something mane, K2 is less than K1. So definitely there will be a decrease in equilibrium constant when you are handling an exothermic reaction as you increase the fixed temperature from T1 to T2. There is a decrease in equilibrium constant. Got it? So
Yes, sir.
এটা লিখিদেল কি এটা লিখিদেল তଳଟା যে ମୁଁ ଲେଖିଛି এটা লিখিଦେଲ
Yes, sir.
Yes, sir.
This I won't tell you now. I will tell you today later. But let us find the equilibrium constant Kp. For the reaction N2 plus 3H2 gives 2 ammonia. Standard enthalpy of formation देई देइछि, del H देई देइछि, enthalpy of formation देइछि, right minus left କରିବାକୁ ପଡିବ, reaction ପାଇଁ right minus left କରିବାକୁ ପଡିବ, predict whether the reaction will be spontaneous, कारण del G not ବାହାର କରିବାକୁ ପଡିବ, ନ ବାହାର କଲେ Kp ବାହାର କରି ପାରିବ ନାହିଁ. Do it. That is the last, I promise. But I will tell you reaction quotient versus equilibrium constant. ଭିତରେ ଆମେ ତିନିଟା କେସ୍ ଷ୍ଟଡି କରିବା. ଯଦି ଇକ୍ୱିଲିବ୍ରିୟମ ଆସିଗଲାଣି ବଦମାସି କରି କିଛି ପ୍ରଡକ୍ଟ କେ ଆଡ୍ କରିଦେଲା, then Q ଟା K equilibrium ଠୁ ଅଧିକା ହେଇଗଲା, then the backward reaction will continue. ତାମାନେ ତାକୁ ସେ ଗ୍ରାଫ ଟାକୁ ତୁମେ ଓଲଟି ଦେବାକୁ ପଡିବ. ଏଇ ଯୋଉ ସେପଟେ କମ ଥିଲା ବର୍ତ୍ତମାନ ଏପଟେ କମ ହେଇଯିବ, ଅଳ୍ପ ଟିକେ ପରେ ପୁଣି ସେ ବନ୍ଦ ହେଇଯିବ. So del G, so called del G dj by dg by dj can never be positive. ସେ ପୁଣି କମିବ, ନେଗେଟିଭ ସ୍ଲୋପ ରୁ କମିକି ଜିରୋ ହବ. ସେଟା ମୁଁ କହିବି, ସେ ତିନିଟା କେସ୍ ମୁଁ ପରେ କହିବି. So it doesn't matter. One is product loaded, reactant loaded. ଯଦି product load କରିଦବ ତାହେଲେ उल्टा डायरेक्शन रे हबो. कारण देखो କହିଲେଣି ଯଦି କହିଲେଣି, ଆଉ ତମେ ତ ଭଲ ପିଲା, ଆଉ ମାଷ୍ଟର ତ ଦେଖୁଛ ଏଇ ଭଳିଆ ପାଗଳ ମାଷ୍ଟର କୁ ପାଗଳ ଷ୍ଟୁଡେଣ୍ଟ. ଦେଖ ତମେ ଏଇଠି ଅଛି, ଏଇ ଜାଗାରେ ଅଛି, ତମେ ଯଦି ତମେ Q ଟା କମ ଅଛି, ସେ ଆସ୍ତେ ଆସ୍ତେ Q ବଢୁଥିବ, ଯେତେବେଳେ Q ଟା କେସି ହେଇଯିବ ତା ମାନେ ଇକ୍ୱିଲିବ୍ରିୟମ ଆସିଗଲାଣି, D ଏଇ ଯୋଉ ସ୍ଲୋପ ଟା ପ୍ୟାରାଲାଲ ହେଲାଣି, ମିନିମମ ପଏଣ୍ଟ ଆସିଗଲାଣି ହେଲା. କିନ୍ତୁ ତମେ ଯଦି ଇକ୍ୱିଲିବ୍ରିୟମ ଆସିଲା ପରେ କିଛି ପ୍ରଡକ୍ଟ ଆଡ୍ କରିଦବ, ତାହେଲେ Q ଟା ପଳେଇଯିବ ଗ୍ରେଟର ଦେନ୍ ଇକ୍ୱିଲିବ୍ରିୟମ କନଷ୍ଟାଣ୍ଟ. ତା ମାନେ ବ୍ୟାକୱାର୍ଡ ରିଆକ୍ସନ ଟା ହବ, ରିଆକ୍ସନ ଟା କଣ୍ଟିନ୍ୟୁ କରିବ, ଏ ରିଆକ୍ସନ ଜଷ୍ଟ ଓଲଟେଇ ଦବ. এইটা সিনা লাগুଛି পজিটিভ স্লোপ, কিন্তু রিয়াকশন আরম্ভ হলা মানে গোটে রিয়াকশন আরম্ভ হলা নেগেটিভ স্লোপ হবো. মানে এইটা উল্টেই দেলে, জাস্ট লেফট কু রাইট করদেলে, পুଣି নেগেটিভ স্লোপ কমি 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 পুଣି যেତେବେଳେ Qটা কে ইকুইলিব্রিয়ম হওয়া পর্যন্ত ব্যাকওয়ার্ড রিয়াকশন চালিথিব. ইউ আন্ডারস্টুড?
Yes, sir.
তো তিনিটা
Yes, sir.
কেস जो ମୁଁ କରିଛି ସେଇଟା ମଧ୍ୟ କହିଦେଲି. ଦେଖ ତମେ ପାଗଳକୁ ମୁଁ ପାଗଳ, ଯେତେବେଳେ Qଟା କେ ଇକୁଇଲିବ୍ରିୟମ ଠୁ ଅଧିକା ହବ, डेफिनेटली लेस हम, यहाँ भूल लिखी लेस हम, इट इज रिएक्टेंट लोडेड, रिएक्टेंट जस्ट नहीं कि रिएक्टेंट अधिका अच्छी, इक्विलिब्रियम आसीनी, the reaction is now running in forward direction until Q is equal to K equilibrium. And G, so called G changes from negative value to 0. Then Q is greater than K equilibrium, product loaded ही जाइए, the reaction will run in backward direction till Q becomes K equilibrium constant, K equilibrium. G changes from same negative value to 0. G can never be positive. That concept you should have. And जदि by chance तमे जति कि नेइचो इक्विलिब्रियम आसी गलानी, किबा तमे जानि करी नेइचो एतिकी देखलो Q is equal to AQ, then reaction is already in equilibrium. आउ जिबार नाही कुआडे बां को डाणु. ए इक्वेशन प्रॉब्लम टा कलो हमें बाहर कर दबा. चलो del HF del HR, del HR of the reaction is equal to right minus eta 0. 0 plus
So
2
minus
into 0 say 0,
92.2 kg.
minus 2 into ammonia रो heat of formation. ଏଇଟା ତ ରିଆକ୍ସନ ଟା, ଏଇ ରିଆକ୍ସନ ସେ ପଚାରୁଛି, ଆଉ ଦରକାର କଣ? 0 0 ସେଇଆ ମାଇନସ୍ heat of
So
formation
minus
data ଦେଇଛି, sorry,
92.2 kg.
2 into minus 46.11. heat of formation of ammonia पर right hand side, sorry,
What's the product minus reactant?
product minus reactant. So 2 into minus 46.11 minus 0. खाली 2 रे गुणिबो आ कोन, गोटे मोल पई डेटा देइछि 2 रे गुणिबो, कारण तार इंडिविजुअल तार एलिमेंट रु तैयारी हेची तेणु डजंट मैटर तुमे तो सेडा शिखिन 0 0 पुट करिकरी बाहर करदलो केते केते बाहरला
Sir, minus
So
92.22.
92 kilojoule.
माइनस 92.00
22.
92.2.
22 डेल एस बाहर करो इंडिविजुअल एंट्रोपी देइची डेल एस नॉट इज इक्वल टू सेमिति प्रोडक्ट 2 into अमोनिया होची 192.45 माइनस नाइट्रोजन गोटे नाइट्रोजन एंट्रोपी होची 191.61 प्लस 3 into हाइड्रोजन एंट्रोपी होची 130.68 केते हला केते हला
Minus 19.668 kilojoule.
शिखला से ओम 6 तारो डेल्टा एस टा किलो जूल केबे हबनी जूल्स हबो डेल्टा एस टा एते चेंज हबनी जूल्स पर केल्विन हला सबु बेले पर सही भूल करछु तमे
Sorry,
डेल्टा
sir.
एच
Sorry, sir.
डेल्टा एच टा किलो जूल्स रे दिया थाए थाए अधिका थाए किंतु डेल एस टा एते चेंज हबनी किलो किलो अनुसार हबनी जूल्स ताको पुनी किलो करियो पड़ियो सो बर्तन डेल जी टा बाहर करो तापरे हमें डेल जी इज इक्वल टू डेल डी नॉट इज इक्वल टू डेल एच माइनस टी डेल एस नॉट सो डेल एच बाहर आगुरु माइनस 92.22 माइनस 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 प्लस हो गला टेम्परेचर को 298 इंटू 0.0196 0.0196 अब से ताकू जेमथि हेले जूल करियो
Sir,
पड़ियो
last भूल थिला delta S not sir वो minus 198.75.
कोठी मो
Sir, delta S not था.
हां तुमे भूल कहिथिलो नै
Yes, sir.
तमे ठीक ठिकाना करूनो मिस्टर ये
तो मु से
ओमकार
करिथिली
घुमिलणी
ना
1
मु करिथिली नै भूल करले
माइनस
198.75.
पॉइंट
75.
सो इठी ताहले 0.1987 0.1987 माइनस माइनस प्लस हो गला सो किलो जूल्स रे केते बाहरला ताको जूल ही करियो पड़ियो इक्विलिब्रियम कांस्टेंट बाहर करियो खाली ना आर रो वैल्यू जूल रे यूज करियो नने सेठी किलो जूल यूज करले भी हबो केते बाहरला इज 92.22 प्लस माइनस 92.22 प्लस 298 into 0.1987 this is going all limits 6:30 ru I mean 10 टा बसिलेनी we are heading towards 4 hours
सर
आज
minus
देखियो
32.99
minus 32.99 kilojoules per mole not per mole for 2 moles it is an extensive property so 2 moles pai hame dekhiche so per mole likhiwani so that is equal to 30 minus 32.99 तापर कोन थिला 99 पर किछ नथिला
मोर आसु minus 33.0074.
है छाड़ो ताले माइनस
33.
33,000 कर दो जूल्स कर दो हैला तुमे
Sir.
वर्तमान यूज करो डेल जी नॉट इज इक्वल टू कौन की कहि परिबो डेल जी नॉट इज इक्वल टू माइनस आरटी 2.303 आरटी लॉन केपी बा सॉरी लॉग केपी 2.303 हैला तले बाहर करो वर्तमान एंटीलॉग नहीं करी बा 10 टू द पावर समथिंग जहां बाहरला समय नहीं हमर समय नहीं वर्तमान जहां बाहरला लिखिवा एंटीलॉग दरकार नहीं डेल जीरो इज इक्वल टू माइनस 2.303 आरटी लॉग केपी बिकॉज गैस अच्छी माने केपी माइनस 2.303 आर हूँ 8.3 नवा टी हूँ 2 केते से कहूँ 298
Yes, sir. 25 degree थिला.
298 into log kp इज इक्वल टू डेल जीटा बाहर कौन -3 3 केते बाहर 3300 ना ना 33,000
Yes, sir. Minus 33,000.
हाँ 33,000 सो माइनस माइनस प्लस हो गला तेणु डेफिनेटली लॉग केपी सिंस डेल्टा जी एते ह्यूजली नेगेटिव बाहर डेफिनेटली एक रु बहुत अधिक बाहर मैथमेटिकली यू कैन से लॉग केपीटा केते बाहरला कह
Sir, 5.793.
5.79 5.793
5.793 माने kp is equal to 10 to the power plus 5.79 so is highly favorable reaction right favored reaction delta zeta negative बाहर थिला हम जानि परछु so it's right favored so more मध्य बाहर
3
केते
to
सेटा
sir 3 to 7.99 SC.
एटा मु जो बाहर करथि डेल एस टा 198 ठीक आछि एटा 922 आछि 9 तमे केते करथिलो डेल एस टा 92.22 मोर भी से आछि एवं हाँ एग्जैक्टली से आछि ताको एंटीलॉग नेले 6.18 इन 10 to the 5 आछि ए तो
No, sir.
yes
Sir,
अरे
anti-lock नेला बेले sir e to the power 5.791 करू.
हाँ ई टू द पावर न करी के 10 to the power कर दोनो बिकॉज़ ए लॉग केपी अछि ना एटी 10 अछि
Okay, sir.
बेस टा
Sorry, sir. ସେଇଟା ଭୁଲ ହେଇଥିଲା.
सेठी जदि लॉग नै थांता ई टू द पावर हे थांता लॉग अछि माने 10 to the
Yes, sir.
10 बेस अछि ताकू
6.18 into 10 to
yes
the
sir
5.
yes sir
बास
ठीक
देखो
अछि
केते ह्यूज केपी बाहरला सो आउ केते गुडा को प्रॉब्लम देइछि एटा तमे करिवो चेष्टा करिवो डेफिनेटली आउ नहले मु तुमको हेल्प करिवि बास दीटा को सार देली आज
सर ए केपी हाई ହେଲା मतलब रिएक्शन टा यील्ड बहुत अधिक दବ
अधिक
ନାଇଁ
हम जदि
କେତେ ବି टाइम
जदि
अनुसार
जदि विलेन ताकू हैरान न करिवो आमे
ओके सर
थर्मोडायनामिकली प्रेडिक्ट करदेले रिएक्शन टा पूरा राइट फेवर्ड माने पूरा परसेंटेज ही बाहर कर दे हबो केते प्रोडक्ट रो परसेंटेज मोर देन 90% बहुत हाईली फेवर्ड 99% हे जिवो इज ए प्रोडक्ट फेवर्ड रिएक्शन इरिवर्सिबल रिएक्शन ताकू आमे practically आमे कहि परिबा इज इरिवर्सिबल रिएक्शन 10 to the 5 10 to the 10 एमते हे गला रिवर्सिबल कारण जेतिक बाट ये फॉरवर्ड रिएक्शन गला बैकवर्ड रिएक्शन गले सेतिक बाट जिवो से 99% जति 1% जिवो अधिकांश रिएक्शन हमर दरकार नै से 1% 0.1% किंतु जोडा को दरकार व्यापार पई ताकू ही नबाक पड़िबो बुझियोस तो
यस सर
किंतु ये रिएक्शन टा प्रकृत रे सेही टेम्परेचर 298 रे फलप्रद हब भिलियनी न करिवो किछ कहि होबनी सेतबे टेम्परेचर बढ़िबा को पड़ी पारे जदियो सैक्रिफाइस करि परियो हब डेल जीटा माइनस केते बाहर थिला 922 ना कोन बाहर थिला ताठु टिके कम ही पारे से माइनस रहू पछे जे टिके हायर टेम्परेचर रे इक्विलिब्रियम कांस्टेंट 10 to the 5 न 10 to the 3 पछे ओ हमरो शीघ्र आस जाऊ इक्विलिब्रियम हो कि नहीं
यस सर
yes sir
so we finished both. Thank you so much for your patience. And guys, if do you have come to this end, I can definitely say that have you subscribed to my channel? I'm not telling to both of you. Perhaps you have subscribed. If not, Omkar, it is your duty to log on to my channel, hit a subscribe button only for
already subscribed sir already
this is this
subscribed
just I'm kidding. I'm sure you have and others who will be watching do so please to encourage me to produce some good videos for our children. Bye bye for kali ame kariba hala
सर सर कल केतेବେଳେ सर संध्या बेले
मोर मु स्ट्रीम बंद कर देली काली हमर हबो सेही संध्या बेले से संध्या बेले टाइम ता hala
ओके सर